Hello, everyone. Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry. I'm a photochemist/photophysicist. I use light to drive chemical processes, and also we monitor those processes with things like time-resolved spectroscopy, emission, absorption, all sorts of stuff. But more importantly, joining me today is Dr. Takemichi Okui. Take, if you wouldn't mind introducing yourself.
Hello, everyone. I'm Takemichi Okui. I usually go by Take. I'm from Department of Physics at FSU. I'm a theoretical physicist. I think about things like dark matter and the Higgs boson at the LHC and stuff like that. So, and currently I'm thinking about magnetic monopoles and primordial black holes, which I hope I have some time to talk about it today.
Oh, yeah, absolutely will.
Yeah.
What do you typically teach?
So I typically teach advanced courses. For example, last semester I taught general relativity to physics majors, and this semester I'm teaching high energy physics to graduate students.
All right, equally important. What game are we starting with?
So we are starting with Salamander, which it's a very old game from 1986, as you can see on the screen. So I encountered this game when it came out when I was I think 12 years old. I think I was either elementary school. Oh, so it's already started?
Yep, you're up.
Oh, okay.
Sorry, I didn't give you the heads up.
Okay. Anyway, so with the beautiful graphics and stereo sound, which was brand new at that time, it was sensational. Yeah, and even now I think you can see that graphics and the beauty of you can appreciate the beauty of the graphics.
I mean, so you'd go to the local arcade, just pump coins into this, basically.
Yeah, so this opportunity is great for me because when I was a kid, I didn't have much. My parents didn't give me much allowance, so to go into arcade and play games was it was an expensive thing to do.
Yeah.
Oops, sorry. Yeah, so this is great because I can play as much as I want.
Oh, yeah. No, if you want to beat this game tonight,
yeah.
We definitely can. It's just going to get...
Yes, with infinite lives.
Yep. Yeah, we'll just keep adding coins. I hit the plus button on the keyboard and we get an additional coin.
Yeah, I think it was either 50 yen or 100 yen, I don't remember, but something like that, which was substantial for a 12-year-old kid. So...
Well, especially games like this that were designed to eat your money, right? They're
yes, of course.
Inherently hard.
Yeah.
These are button mashers too. So when was the last time you played this game?
I think in the real life, of course, it was maybe 1987, 88 or something. Yeah. But I played on the emulator like this one. Mm-hmm. Yeah, later.
Yes, we're using a MAME emulator for this and running it on a separate computer. And we're playing with an Xbox 360 controller, so Take, I hope the joystick's treating you okay.
Yeah. Oh. Okay, so now here comes the brain.
All right, Codemaster says, hello, Dr. Take.
Hello.
Two nerds, one black hole is Luke. It says, sup, Take, it's Luke. Is that one of your students?
Hi, Luke. Yeah, he's my former student.
Luke, welcome to the stream. Thank you for joining us on Ask a Scientist Gaming. This is kind of what we do. We basically are going to hang out, drink alcohol. Take's going to play a whole bunch of video games, and we're just going to answer questions about theoretical particle physics. But we'll let you get through the first boss before.
Yeah, this is playing video game while talking of physics is a considerable challenge for me. I can barely, my family knows this very well, but I can barely drive while talking.
Yeah.
Yeah. But I'm an extremely single task person.
Oh.
My multitasking is not my forte.
No worries. That's what the alcohol is for.
Yeah, well, that just makes it even worse. Or that gives an excuse for not doing things very well.
Two nerds, one black hole. Shut up and play. Just kidding. Sir Fink, welcome to the stream. They said, hello, Take. Those are presumably your students, former students, graduate students. Welcome all to the stream. You can watch Take play a bunch of video games. Does it feel like it's coming back?
Mm-hmm.
So how far did you make it in this game in the arcade? Did you ever end up beating it?
No, definitely not beating it. Yeah. So this game has 6 stages, and I think the farthest I made, that's probably third stage.
Third stage.
Yeah.
Is tonight the night? Should we do it? Commit and beat this? We got 3 hours. Infinite lives.
Infinite Lives, great. Yeah. Oh, that was second boss.
Codemaster.
But with no weapons. So that would be very difficult, I think.
Yeah.
Because this boss is fast, so I cannot catch up without getting speed up. So. But since they have infinite lives, maybe I just
Surfing Sal
do
is
the kamikaze attack.
like, does that do damage? If you
I don't know.
if you fly into it?
Well, let me try.
Testable hypothesis.
Yeah.
Fly over the
No.
center. No, nothing. Presumably it changes color. All right. Surfing Sal is a former grad student as well. Oh, Codemaster. Sheldon is a theoretical particle physicist too, right? Presumably that's Sheldon from Big Bang Theory.
Yeah.
Have you seen Big Bang Theory? What are your thoughts
Yes.
on that?
It's really funny. Yeah, I find it hilarious. And I think
It's a reasonable representation of particle physics.
I think it represents what particle physics might be feeling inside pretty well. I don't think we say all of that.
You know, vocalize
Right.
it.
Yeah,
it's
because
unacceptable.
we are a little bit more socially trained than Sheldon.
Yeah, you have to be.
But what he's feeling is very similar to what we might be feeling. Things. Yeah.
It's pretty fun. I would have never.
Yeah. So
thought
this is
that.
the third stage, which is very beautiful.
So do you get the impression? I've never really watched the show. I've seen clips, but do you get the impression they actually consult with physicists?
I think so. So the so Sheldon's room has whiteboard, like with equations on it, or diagrams, stuff like that. Those equations and diagrams are actually pretty accurate, although there is no context for it. Like, but the actual equation itself is actually correct. Yeah, just there's no there's no logic from equation to equation.
They're just filling
but each
space.
equation looks correct. Yeah. So I think they must have some consultant.
Non-dairy Neutrino, welcome back. Neutrino, you sound like a physicist. It's good to have you on the stream. If you have questions for Take, he is happy to answer. He's a theoretical particle physicist that studies a lot of things. So, I mean, I guess let's start with a broad question. Not necessarily science related, but one thing we're always curious about is the journey that took our guests from where they were to where they are now. So, 12-year-old Take playing Salamander in the arcade probably didn't think he was going to be a particle physicist professor at FSU.
No,
So
definitely not.
What was your
I
journey?
don't think at 12 years, I don't think I even knew that there's a occupation called professor. Yeah, I mean, of course I knew school teachers.
Yeah,
but
I
I
know.
didn't think. I don't think I knew there's a job for. I mean, I think I knew that there's a job called scientist. But university professor was not something I knew. Yeah.
So grade school, when did you fall in love with science? When was your...
So actually, I was always a science-oriented kid, like, as far as I remember. Yeah, so just like any little kid, I started from living things around me, like bugs and insects and stuff. But then I was also interested in...
What?
Oh.
Over? No!
I mean, it's not possible for me to pay attention while I'm talking.
Yeah. Well, I didn't pay attention either. All right. Oh, maybe.
Yeah, so I was always interested in, mechanical things and electrical things and stuff like that.
So even with the credits, it might not let you keep playing. That's interesting. It
Can
might
you
only
add?
give you-
Can you add money while I'm playing?
Let me see. So it's giving you 26 lives, but credits won't give you... I don't think they give you more than 26. So never mind. We might not have infinite lives, ladies and gentlemen.
I got force field, so maybe that's better.
Game over, take a drink. Speaking of which, Take, what are we drinking tonight?
It's called a nigori sake. So it's a type of sake, but it's not something that is probably most common type of sake in the United States. So it has some. It's not transparent. It's. Can you show that to the screen?
Yeah. I don't know if you
Yeah,
guys can see because the
yeah.
green screen effect is Take. Look right.
Yeah, it's white.
Transparent.
Yeah, it's not transparent. It's white, like kind of diluted milk kind of texture. So it has basically, it's kind of like orange juice with pulp. It has some remnant from the process that of making sake, and some people like this better because it's milder than usual sake. But to be honest, I don't have much experience with this type of sake. It's actually interesting.
Yeah. In Take's defense, he was like, "Oh, I'll drink whatever you want, but I use this stream as an excuse to try different drinks. And you're my first Japanese guest." And he was kind enough. I'm like, "Is there a Japanese drink you want me to find?" And he suggested this one, and I'm really happy with it. I like. It's not too sweet. It's got a little bit of bitter associated with it.
Anyway, so coming back to my path. So I was always interested in scientific thing, and I think my dream as a kid was to have a lab in my house, like a chemistry lab kind of thing. But we lived in a very small apartment, so that wasn't possible. So I didn't even know what kind of chemical things to buy, or even where to get it from. Yeah. So I think I was mostly playing with, things like, for example, there was a old tape recorder, a cassette tape player, right? Cassette tape. I don't know whether people nowadays know what cassette tape is. Yeah. And so there's a good expensive one that my dad didn't let me touch, but there's an old one that I was allowed to take them apart and see what's inside and stuff. So I saw what's inside, and then building them back again. I also took apart some telephone and building them back again. So actually there was some local telephone company held like telephone building contest. So basically, you build a phone, right?
Just from scratch.
From scratch. Yeah. I mean, there are parts, of course, but so you basically have to combine the parts to build a working phone, right? And actually, I was in the first place in that contest.
Oh, nice.
Yeah. So that was kind of fun. Yeah.
All right. So non-dairy neutrino redeemed. Take a drink. Maybe we'll wait till you have a free moment. But non-dairy, thank you as always for joining us. Cheers, Take. Hey, you got one hand. It's good.
Cheers.
So 16 lives left. I have no idea how to get infinite lives on this. I thought the credits would do it, but that just lets you play over and over again.
So what else did I do as a kid?
Well, so
yeah. Oh, actually, around the same time I was in. So I found that there's a sort of electronics club in the next town. So I took train every week to go to the electronic club, and so stuff from simple crystal radio. Is that how you call it in English? Like it's a radio, but it just use some kind of crystal instead of diode.
Oh, that's interesting. No, I'm not familiar.
And then you don't even need a power to operate it, actually. Yeah, so it's a very primitive type of radio. And so I started from that, and then then soon we started. What do you call it? Like, so there's a sort of board, which has so it's a kind of plastic kind of board which has a copper coating on it, like just uniform copper coating on it. And then so I would design my circuit, and then I draw my circuit with a pen. And then you put it in some chemical, and then that will melt the copper except the parts except
covered.
the ink part.
It's lithography. That's clever.
Yeah. So we did things like that.
That's
and I really enjoy those activities. And then I was also in the.
This is brutal.
There's a safe zone around here where you don't get hit, but I think it was around here.
Are those loops random? Is that?
No, it's not. Everything is exactly. You can memorize all the
I see. It's the same.
every
time.
single appearance of enemies, and then yeah.
All right. So you went to undergrad. I can't remember which school you were at. You were at
So I went
Hokkaido
to
University.
Hokkaido University. That's in Sapporo, city called Sapporo, which is famous for its beer. Yeah, so Sapporo Beer Factory was actually not so far from the campus.
I see.
And you could go there, and then of course you have to pay, but you can drink beer out of, I don't know, their barrel.
Yeah, still, yeah.
Yeah, and then I think they also have sort of some barbecue so that you can just eat and drink, and yeah.
And so there, you started out as a physics major, or you
No, so
too?
I was interested in all kinds of science, right? So when I was a freshman, I took every single science courses available for freshmen. Yeah, so my schedule was completely full.
Yeah.
With all the biology, geology, and everything. Yeah, so for example, in the geology, I think it was part of that geology course. We went to some mountains to collect some rock, and
Oh, that's fun.
and then also placed I don't know how you call it in English, but the this equipment that measures the earthquake.
Oh, yeah.
Yeah, seismometer or something like that. Oh, I died again.
A Richter scale is the metric, but yeah.
Anyway,
I don't
so
remember what it's called.
we have to play. We placed those devices every I don't know, couple 100 meters or something to
All right.
measure to get some data.
Codemaster, do you know how to do infinite lives on this?
No.
If you do, they said it's the stream setup. I can help. So there's a menu option here, but I don't know if there's anything that gives you.
Yeah, because I'm paying zero attention.
Yeah, exactly. Well, no worries. I mean, if you're okay playing over and over again,
Yeah,
brings you back to your childhood.
unlike talking while driving. There's no consequences.
Yeah, exactly. Zero risk. All right.
There's no life risk.
Codemaster, if you have a link or something or an explanation, press plus while playing. I did, and it's not giving me additional credits. So let's try it again. So you can hear the sound where it's adding credits, but it's not adding lives. So I don't know what it's
But they
doing.
have 26 lives.
Yeah, so you start out with 26 no matter what, but it doesn't go any
Really,
higher
that's
or
very
lower.
generous.
Oh.
26 lives.
So yeah, we're trying to add credits, but nothing's happening. So it goes. All right, so you took a whole bunch of classes. You fell in love with physics?
Yeah, so I think I had to decide. So basically my logic was that, so basically everything was interesting. So I couldn't choose. So basically what I decided is that so the only criteria I could impose for my selection was that the sort of logical hierarchy of the subjects. For example, like biological phenomena based on chemical phenomena, and then chemical and reactions you can understand in terms of quantum mechanics and so forth, right? So when I traced all the what could be deduced from what kind of thing, I decided that, okay, so let's start from physics, and then once I master physics, I can move on to whatever I want. But then I'm just
ambitious.
Yeah. So that was my naive thinking.
So Codemaster is an interesting idea. We could have a player 2 floating around, and as long as you don't die at the same time as player 2, or you don't both lose 26 lives at the same time.
But if player 2 is floating, the player 2 would die, right?
Yep. But it'll keep dying, but we can keep respawning. So after... Well, let's give it a try. I'm curious. Let's try this, Codemaster. So I'm just going to take over. Sorry. I just need to see what controls player 2. Coin for player 2 is 6, and start is 2. Okay. All right. All right, you're back. All right, there we go. We have sacrificial player 2, Codemaster with testable hypothesis right here. It's a good distraction. So you're in, yeah, you're that one.
Yeah, so basically brain is attracted to the second player.
Or one arm is attracted to each. That's fun. All right, we'll see if we can get this continue option. Codemaster, thank you very much. Start to respawn. We'll give it a try. This is fun. I like it. So I could control that theoretically with the keyboard, but I don't know the key bindings off the top of my head. But regardless, okay, so physics is where you went. Then at some point you decided to go to grad school.
Yeah.
That was during undergrad you committed?
Yeah, I think I was pretty sure that I would be doing continuing physics. And then, you know, the biggest decision for me was, of course, to come to the United States. And that is, you know, both for professional reasons as well as cultural reasons. I mean, it was obvious that lots of things are going on in the United States, right? So I wanted to come to the United States to study. Also, like culturally, I was kind of sick of being in Japan. I was there for 23 years, and it's kind of it's very stifling society. I mean, it's lots of social expectations, and everybody has to do the same thing. I call Japan country of Borgs because everybody's the same.
Yeah. Well, academia, there's a
so actually,
power dynamic.
If you just academia is a little bit different, especially if you look at theoretical physics in Japan. They are almost not like Japanese people because they are so weird and different. But I didn't know that.
Yeah.
I think I'm very happy that I came here because it's very different from. I feel much freer here. Yeah. So I think boss just died because I was too slow.
So he's got one life left. We're gonna find out.
Yes,
Codemaster.
let's
See if you're right. Player 2 found the sweet spot on this one, though. Look at him just floating there. All right, so you applied to a bunch of grad schools. Any particular reason why you chose the schools you applied to?
So unlike now, information was very limited at that time, right? So there was internet, but it was very difficult to still use. I mean, Google just came around, and it was not easy to get information. So even though each university had a web page for their grad school application, I still basically what I had to do was to call the phone number on the web page to ask them to send application package to me by mail. Yeah. So it was kind of like that. It was so I didn't. So unlike now, I didn't know which department is good. Which department is good at particle physics. It was very difficult to get the information. So I just applied to the schools I've heard of.
Yeah.
I mean, so
you got into Berkeley.
Yeah. So I was very lucky that I got into Berkeley. Yeah. I still remember. So I landed on the United States on July 5th of 98. And I still remember so I think I landed on the San Jose airport instead of San Francisco, because when I look at the world map, San Jose and Berkeley looked very close. So
Good point.
So I didn't have any. So so let's go to San Jose because that was cheaper than going to San Francisco. Yeah. But I remember when I came out of the airport, it was pristine blue sky.
Yeah.
And it was beautiful. Yeah.
Yeah, it's deceptive how big the U.S. is.
Yeah.
I mean, it's
So then it was a kind of long trip to go from there to Berkeley. So first I got on the hotel shuttle that goes to hotel in San Francisco. So I didn't have, of course, any reservation with the hotel, but they don't check, right?
Yeah.
So I took a hotel shuttle to one of the hotels in San Francisco, and from San Francisco, I figured that I can take train called BART. That stands for Bay Area Rapid Transit. So I went to the BART station. I looked at the map and I figured out where the BART station was, and I walked there. And then I saw a platform with only like a 10 centimeter high. So I kind of beginning to get confused by that.
Codemaster's strategy is working perfectly here.
Okay.
So you just came back with 26
great.
lives.
Wow.
So Codemaster,
Genius.
problem solving.
Genius.
Uncle Bill, welcome back to the stream. It's a pleasure to have you as always. We're talking particle physics tonight while playing Salamander and gaming the system. Well done, Codemaster. Points for you. That's why we do the Carl Sagan. Brilliant. Absolutely brilliant.
Yes. So what was this?
Grad school.
So then I was confused by this 10 centimeter high platform on the road, and then I saw cable car coming. Okay, so then I thought, okay, so this is not Bay Area Rapid Transit, right? So I thought even in the United States, cable car can't be that fast. So then I realized that the BART was in the underground. So there was I couldn't tell the difference between cable car station and underground BART station. So I went downstairs. Anyway, so after a long trip from Southwest Berkeley, I came to Berkeley.
This is brutal.
Yeah,
Holy
I remember there was some sweet spot, I think around here.
I mean,
maybe not.
Player 2 is pretty close. Also, Codemaster is totally not your son. I think it's your son. Codemaster, thank you for joining us. Thank you for the advice. All right, Don, there was a comment from Sir Finksalt related to your career path. Tell them how competitive the field was when you were looking for professorship.
It was very competitive. So
it's always competitive.
It's always competitive, and there are ups and downs in terms of the number of jobs and stuff like that. But my year was especially low in terms of the number of jobs. So in theory, there are only like 10 hires in theoretical particle physics that year in the entire North America.
Jeez.
Yeah, including Canada. Yeah. So I'm very lucky that I landed on one of the jobs.
I mean, being on the other side of the hiring process, I'm amazed any of us get hired. Like it's such.
It's such a random process.
Yeah, and it's luck. It has nothing to do with your CV. It's like what fits the department, what matches needs, where the funding is. Like
I realized that too. Whoa, this is brutal.
Oof. We got your back. Name Luke. Uncle Bill running 3 tabs at once.
Yeah. So what I always tell my students is that getting a job is very difficult. Even getting postdoc can be difficult. So I always tell them that the primary reason that you do this thing is because you like it.
Yeah.
Yeah. Otherwise, can be very, very depressing or discouraging. But if you enjoy the subject, it's all worth it. It's a fantastic subject. Yeah.
I mean, and honestly, the worst case scenario is you don't get a job as a professor and you get paid more to work less. So it's not that bad not being a professor.
Yeah.
I mean, it's like we treat it in academia as the pinnacle of, science and research, but really you can be successful anywhere, whether it's industry, national lab, academia, whatever it be. Academia gives us the most freedom to pursue our ideas.
Right.
So that's kind of what pulled me to this field. It's worth the depression. Thank you, two nerds. There are ups and downs. It is a extreme roller coaster, that's for sure.
Yeah.
I mean, good and bad. Like I had a student defend their thesis yesterday, and it was amazing.
Yeah, no, I don't mean to discourage them.
Yeah.
I just
no, it's the reality, though. I mean, it's worth. Worth sharing that for sure.
But it's very important to figure out what they really want to do before they plunge into whatever.
So for those of you not familiar, Uncle Bill in chat, he's one of the founders of something called the Knowledge Fellowship. He's one of the gatekeepers on basically it's a compendium of all sorts of science and education related streamers. And so he's a regular supporter of our channel as well as others. Apparently had like several tabs open and 3 of us called him out. So Uncle Bill, thank you for joining us. We always appreciate the support. Check out the Knowledge Fellowship if you guys want to check out other educational streamers, physics, biology, chemistry, whatever. I mean, even craftsman people, there's gem cutters, there's electricians, there's all sorts of stuff. It's really, really fun. So yeah, check that out if you're interested in educational streamers. Careful, you can't respawn on that level. Oh, is it the last one?
Yeah, this is the last stage.
We'll see if...
Yeah, I never made it this far.
No, it doesn't let you respawn. So player 2 is done.
Oh, then I'm done too.
I mean, we probably should have killed you off, got you 26 live. Jeez. This is brutal. Yeah, the hitboxes are ridiculous. There's a couple really fun Japanese arcade games where are you familiar with hitboxes? Like the detection zone for where you get damage? Yeah. Have you heard of these 1-pixel hitbox games?
No.
Where the screen is just filled with spam, and your character looks like that, but their actual hitbox is 1 pixel. And so you can find very small pockets where you survive.
Oh, I'm only 1 life left.
Well, make it count.
Ah. Oh, wait. This is the last one? Oh, yeah. Yeah, this is the last one. Okay, so now...
Danger.
Yes. It's funny that of course, when I was 12 years old, I didn't understand these English words.
Uncle Bill, I don't think I've added you permissioned post links. Let me see if I have.
That was the last one. See,
yeah.
If I had beaten that one, that
was the boss.
Yeah, that was the final boss.
I mean, so we should strategize. We should have you lose all your lives and get 26 going into that level. Have both the character. Well, I guess it doesn't matter on player 2 on that one. Uncle Bill, I don't think you have permissions. I'll have to add you as a VIP. Give me 1 second.
But that's the farthest I made.
Oh, congratulations, Uncle Bill. There we go. Okay, now you should be able to paste a link. Maybe? Maybe not. Let me try again. Oh, there we go. Yeah, I gave you permission. All right, we're going to try again. We'll do both players. We're going to make sure we have enough credits. All right, Take, are you ready?
Yes.
We should put up a prediction before we commit. Which one do you want to do?
I don't know. I can't. Whatever you like. Whatever you find interesting.
Which one do you want to talk about?
Let's see.
You should turn up the OST. What is OST?
Original soundtrack.
Oh, music's not loud enough? All right, let me turn up the jams a little bit for you guys. All right, let me know if it's too loud. Ooh, Sir Fink. Take, what do you think about the recent advancements in AI like GPT or Chat GPT?
So my colleague, Toby, in his colloquium talk, he started out his colloquium talk by asking ChatGPT to describe standard model particle physics, 10 sentences, and he graded the ChatGPT's answers. It was about 50%.
That's not bad.
Yeah, so So his point was that we still need professors like him, so we should give him tenure, stuff like that.
At least right now, 5 years.
So I think I don't think it can do physics yet, but it's very interesting what kind of things it could do.
And it can answer physics test questions.
If it's like simple question like what is the electron, or like what's the spin of electron, or stuff like that, I think it can answer perfectly because it's Google, right?
Yeah.
I mean internet, right?
Yep.
I don't think it can write a paper yet. I mean, we try a couple of things, just for fun, and it kind of spits out right words, but they are not really connected in the right way because GPT has no brain, right?
Big Bike Japan, thank you for the follow. Thank you for joining us. If you have questions, throw them in chat. Taka is happy to answer those.
Yeah.
We're going to throw a prediction up there right now.
Just choose whatever, because I'm too busy with.
Yeah, let me know if player 2 dies, someone, and I'll make sure player 2 gets back in. So on Twitch, we have predictions. Usually they're used for gaming. On this stream, we use them for science-related questions. So if you guys aren't following us, click the follow button on the screen, get your standard internet units indicated by the Xi. You can bet your points accordingly. You can basically say how confident you are in the answer to this question and bet as many of those internet points as you want. They are useless outside of the stream, but on the stream, you can make us take a drink. You can request a factoid. You can unlock emotes. Sir Fink, thank you for the follow. Enjoy your points. All right, we're going to put a prediction up right now. On the top of your chat, click that predict button. You can click 10 over and over again, or you can put an arbitrary amount of points. Two nerds, thank you for the follow. The question is, what came first, gravity or light? This is not a philosophical chicken or egg question. This one does have answers according to modern physics. So the question is, which came first, gravity or light? And so use your standard internet units, make your decision. Is it gravity? Is it light? Which one of those two came first? Well, that's fun. The laser really helps.
Yeah, but I don't have enough speed. Let's see. I died.
All right, you guys have about a minute and 30 seconds left. Which came first, gravity or light? You get to ask some of the really fun, fundamental questions about the universe, and origins, and things like that.
Yeah, that's what we do.
We have one person that says gravity and nobody is betting otherwise. Make your prediction.
Wait, no one's betting, or
you mean the actual thing or the knowledge of it? According to our most accepted model of physics, we'll say.
Yeah,
what is our understanding of what
which came first in the evolution of the universe? That's what question means.
Mm-hmm. And this is pretty universally accepted in the particle physics community, or the.
Yeah, I think so. I mean, we don't frame the question in this way normally, right? But I think if I say what my answer is, I think everybody will agree.
That's fair.
With my answer, yeah.
something weak, electro-weak separation. That's non-dairy neutrinos. All right, you guys have about 10 seconds left. Everyone so far has said gravity. Nobody's going to dark horse bet on light. All right, Take, what's the answer?
Answer is gravity.
All right, congratulations, everyone. You got that one right. Why is it gravity?
So gravity is the, according to Einstein general theory of relativity, gravity is the curvature of space-time. So as long as space-time existed, gravity existed as much. So we don't know when space-time was formed. We don't know that, but we are sure that whenever that was, gravity was there from that time at least. On the other hand, light is actually, electromagnetic force is not actually a sort of original force. The original force was called electroweak force, which is a combination of electromagnetism and weak nuclear force. So weak nuclear force is the force responsible for radioactive decay, like beta decay, for example. And it was weak force is not just, it's not like weak force and electromagnetic force together, but it's sort of different. I mean, it's a mixture of both. So it's neither weak nor electromagnetic. It's kind of strange mixture. And then, and at one time in the evolution universe, relatively recent, I would say, they split up. So this weak force split it into weak force and then electromagnetic force. So that's the moment where electromagnetic was born in the universe. Yeah. Before that, it was some kind of strange force. That is not.
So congratulations to all four of you that said gravity. You won. You didn't win any internet points because nobody bet against you. But congratulations. Pride was on the line and you got it correct. We'll say those are 4 students, so you should be proud of them getting that right.
What happened to? Oh, so I should press. Yeah.
There we go. Oh, that was. I'm glad you caught that because player 2 is about to die too. All right, player 2's back in. Trying to keep track of it.
So I'm.
All right, so gravity came first because space had to exist before light could exist.
Yes. That's the short answer.
That's the gist of it. That's pretty fun. All right, Take, thank you for joining me, everyone. If you have physics questions of any kind, Take's happy to answer them. He's an expert in theoretical particle physics, thinking about things like magnetic monopoles, about primordial black holes, also talking about gravity and light.
I work on cosmology too, so I also welcome any question about cosmology.
I mean, so that's interesting. So you work in a broad space of physics. You're not doing a particular measurement or data set. What is your source of data? You look at anything available and fit it to the model?
So it depends on so I will look at any useful data depending on the project. So, for example, if I'm interested in building a model of dark matter, then of course I will look at experimental limits on the mass of the dark matter and cross section of dark matter scan and stuff like that. But there also there's no standard recipe that I could follow to make sure that I can cover all the relevant data. It's kind of like art.
Anyone with epilepsy warning on seizures is like, wow, that was terrible. What happened there?
So, because basically, when I build a model, I write down just what physicists call Lagrangian on my theory, and then basically, I have to deduce all possible consequences what Lagrangian I calculate, and then compare with data.
I see.
But the deriving all possible consequences, that's a difficult part, of course. But I cannot derive all of them, and so I should only derive the relevant ones. But to judge what's relevant and not relevant requires experience and intuition, and so that's why I call it art. Yeah.
That makes sense. Non-dairy neutrino has a follow-up. Actually, that makes me wonder, what's the current community consensus on the legitimacy of the graviton?
Legitimacy of graviton.
Or maybe speak on your behalf and then what the community thinks? Well, what's your stance on gravitons?
Well, I think I can speak for the community. Theoretically, there is no doubt that gravitons exist. But the gravitons have not been experimentally detected. So gravitational waves, as many of you know, gravitational waves have been detected directly by experiment called LIGO. And those are classical gravitational waves. That's analogous to classical electromagnetic radiation. But just like if you quantize electromagnetic waves, you get photons, that's particle of light, right? So if you quantize gravitational waves, you will get gravitons. And since we believe the world is quantum mechanical, I mean, we already know that pretty much 99% of the world is quantum mechanical. And then if this 1% is gravity, it is not, it's not consistent to think this 1% is classical and 99% is quantum. Right? So we all believe that gravity should be quantized as well. And once you do that, you get gravitons. That's pretty straightforward.
Oh, that's fun. Non-dairy neutrino is about an hour and a half away from LIGO in Washington.
Oh, cool.
Yeah, that's pretty fun. All right, Codemaster wants to know, do you think it's likely that primordial black holes are the secret behind dark matter?
It is possible. It is certainly it's certainly a possibility that the dark matter is actually
Is this the last level?
last level. Yeah, actually.
Oh no, we should have caught the dying beforehand. I didn't know when it was happening. So that last, okay.
Okay, so same situation.
So you have 10 lives left.
That's
No
hard.
pressure.
Because after this, there's Moai,
Yeah.
and then last boss, which. So I know all this sequence because of when I was a kid, I was watching, all the other good players play the game.
Yeah.
So I didn't have money, but then other people had, right?
Yeah, and they just played it.
And other people also much better at playing the game. So it's kind of like, so when so my son loves watching other people playing video games on YouTube. And I was like,
And Twitch.
what's the point of watching other people playing games, right? But then I realized I was doing the same thing when I was a kid. Just instead of YouTube, I was physically at the arcade place and watching other people playing games. So the same thing, yeah. Okay. Almost.
Non-dairy neutrino. I had a chance to get a private tour of the LIGO facility a few years ago, and it was great. Super exciting to see just be in that space.
I'm
Especially
very
the
jealous.
mission control with all the big screens that look at the interferometer data. So one of my favorite physics experiments, it's in Japan, the Super Kamido, it's the PMP.
Kamiokande?
Yeah, Kamiokande. Have you seen that space? Have you ever visited that?
No, but I was in Japan when Super Kamiokande announced this groundbreaking experimental evidence that neutrinos have mass. That was 97, and I was just graduating from Hokkaido University, and we had a speaker from Super Kamiokande talking about the discovery. So I remember the excitement. Yeah.
That's awesome.
So
All
actually,
right.
when I came to Berkeley, first thing I did was I joined a neutrino experiment group.
Oh,
Yeah, so I started out as an experimentalist.
non-dairy neutrino is redeemed. Take a drink. So Take, you're out of. You want more?
Sure, yeah. But then soon I realized I'm better at doing theory than experiments. So I switched.
All right. You ready?
Yeah.
Let's do it again. All right. And cheers. Who was that? Non-dairy neutrino. Thank you for making us take a drink. We're drinking on a Wednesday night. Do you teach tomorrow?
Yeah, tomorrow morning,
What time?
9:45.
Okay, that's a little better. I apologize for taking you out till 11 o'clock
No,
at night.
that's not a problem.
It was one of those when we were deciding a time window, we kind of thought, if we want to reach people on the
Yeah,
West
I could argue that this is more important than my class because my class has it's an advanced graduate student course, so I have a very small number of students. But I'm reaching out more people right now, right?
Yeah, we'll probably get 100 or so people throughout the night.
So I could argue that this is better for science than my class.
Well, also, video gaming and drinking is more fun than teaching. Sorry, students. I love teaching, but also...
Yes, I love teaching too.
Yeah, no, it's very fun, but also hanging out and drinking. What course is it? What's the name of it?
High Energy Physics 1, so it's part of 2 semester courses.
That's awesome. LIGO had some of the most incredible data I've ever seen.
Yes.
They presented their results at a colloquium at FSU.
It's just amazing experiment.
No, I love the big science experiments. I mean, physics has the best ones, right? From the telescopes to the accelerators.
Yeah. Although that's a part I couldn't enjoy when I was in the neutrino experiment. The collaboration was too big, and then there are too many meetings.
Yeah.
I don't like meetings.
And too many authors on those papers. 100 or so authors on each paper. Yeah. I hear that my quantum and computational chemistry course has 5 people in it. Yeah, that sounds about right. But Master, when I went to the FSU physics open house, I learned about the Dune experiment to detect neutrinos. How confident can the researchers be that there's only neutrinos by the time the matter reaches the other facility? What is the Dune experiment? Let's start there.
Dune experiment, of course I'm not in a collaboration, but Dune experiment is an experiment where so they shoot a neutrino beam from Fermilab, that's a national lab near Chicago, and then detect the neutrinos in South Dakota. So detector is a nearly almost 1,000 kilometers away from the beam. I mean the Fermilab. And this long distance is very important for probing the property of neutrinos in the range that we are interested in. And so it's a big experiment. It's actually the flagship experiment in US neutrino physics. So it's one of the major things that are going on in the field. Right. Actually, we just hired a new faculty member working on Dune.
Oh, that's fun. This year?
Yeah. So she's already here.
Oh, wow.
Yeah. She was hired last year, and then she's here since last semester.
Does she play video games?
That's a good question I could ask. She's the next door. Her office is next to mine, so I could ask.
So what do they use for the neutrino source? How do they control generation of neutrinos?
I'm not experimentalist. I don't know the details. But my understanding is that they have some control over the energy of the beam and stuff like. Although maybe not in the real time.
Yeah.
But they could change. And
there too.
I could be lying, but the I think that's the case. So this experiment. So point of this experiment is to so maybe I should explain what neutrinos are. And so neutrinos are very light particle, almost massless, and then key is this almost part. And so then it rarely interacts with particles like electrons and protons that are so that like gazillions of neutrinos are going through your body every second, but of course no one feels it, right? So that's how rare neutrinos interact. So actually you need so there's a lot of waste. So beam's intense beam, but of course almost no neutrinos in that beam is detected. This basically it's wasted. Even though the detector sitting in the South Dakota is a huge, so you need a lot of target material because they interact so rarely, right? And anyway, so that's how feebly neutrinos interact. And the reason that this particle is so interesting is because in the standard model of particle physics, neutrinos are predicted to be massless, no mass. And there are 3 types of neutrinos in the standard model, and then in the standard model those 3 types do not convert to each other. Okay, so if neutrinos are born as one type, then it would stay forever as that type of neutrino. But then what was discovered by Super Kamiyo Kande in 1997 was that neutrinos change species. So it was born as one type and then we will detect it as a different type. And that is only possible when the neutrinos have different masses. And of course, for them to have different masses, their masses have to be not zero, right? At least, maybe one of them could be zero, but not the remaining two.
Yeah.
So then this is evidence against the standard model. So we know that something else has to be going on. So that's why neutrino is interesting, because it is it's sort of a window into physics, new physics beyond the standard model. And other evidence for physics beyond the standard model is dark matter. So there is no dark matter candidate within the standard model. So we definitely need something new, some new particles, or maybe primordial black holes. And black holes itself could be called standard model because it's just the gravity, right? Or space-time. The space-time is already part of the standard model. But to make primordial black holes, we need new physics. So in that way, it's also evidence.
Oh no!
Oh,
You both died at the same time and started over. I was watching that unfold.
do other game.
It's up to you. Do you want to play another one, or you want to keep doing this one?
Yeah, maybe we can change the different games so that the audience can see different games.
We're about 56 minutes in, so we can change it up a little bit.
Yeah. So I have.
All right,
I have like a 6 games or something.
Yeah, I can get. I'll get us to a different
180
game.
minutes.
In the meantime, Uncle Bill wants to know. I'm assuming the beam travels that distance through the crust of the Earth. It seems like a lot would be filtered out.
Well, but not much because neutrinos barely interact. Yeah.
So a certain fraction does disappear. Should we do Space Harrier? That's kind of a fun one. That's a very different, different style.
Different style.
I think this one would be fun. So, all right, we're moving on to
so-
Space Harrier.
So add infinite money.
Yeah, this one I think we get infinite lives.
Welcome to the fantasy zone. Get ready.
Oh, that's interesting.
If you hear that beeping, that is me giving Take a whole bunch of lives. All right.
This was also sensational when it came out.
Yeah.
85 or something.
So I was reading up on this game a little bit. Originally, it was supposed to be like a spaceship flying, but then they changed it to a
in the
person.
prototype version, it was a spaceship.
Do you know why they changed it?
I don't know why they changed it, but maybe this is more fun. I don't know.
Sir Fink, I loved this game.
And this voice was also sensational at that time. And anything that had a voice was sensational at that time.
Right, the neutrinos are less likely to interact than others. Yeah, I mean,
much less.
I mean, that's why they made the
I think
Kamiyo Kande, right? It was a huge pool of water, and every once in a while, it interacts with the hydrogen, oxygen, something.
I mean, a lot of people might think you can have a piece of lead to stop particles in radiation, but it is very difficult to stop neutrinos even with a kilometer-long, thick piece of lead.
Even with the crust of the Earth. Yeah. No, that makes sense. All right, Sir Fink, Luke and I are disagreeing right now. Is the gravitational center of mass of the solar system always within the sun?
Always within the sun? I'm not sure about. I mean, it's pretty much. 99% of the mass of the solar system is in the sun.
So it has to be.
So probably near the sun.
Yeah.
I don't know where exactly it is. I mean, I can't do it right now, but any physics student could calculate that.
The question is, can GPT chat find the answer to that question? Luke and Sir Fink,
maybe
you should
Google can answer.
search the answer, center of the solar system. If 90% of the mass is, and the sun is huge compared to everything else, it'd have to be in the, even casual math.
And that's crucial for our solar system. Most of the mass is in the sun. So that gives a stability to the motion of planets, which was necessary for our lives to thrive for billion years. Maybe not billion years, but
All right, we should do another prediction.
It is not possible to have a Star Wars system with two suns. And,
The binary.
yeah, then the motion would be chaotic, and it's not possible to have stability.
So there's a book series. The author's from China. It's called Three Body Problem. It's about a system with three suns, and people calling out for help because the suns are so chaotic it's going to destroy life. Just kind of a fun take on it, but life probably wouldn't have time to evolve in that type of system.
Right.
All right, so which one should we do?
Predictions?
Yep. We have infinite lives on this one, so
Okay.
which one do you want to do?
Get ready.
We're due for another prediction.
You can do the black hole one.
Yeah, that's fun. It's one you're excited to talk about. Cuddle Puppy. When people ask me if I have a degree in theoretical physics, I say I have a theoretical degree in physics.
Get ready.
Classic. It's like my theoretical friends. No, they're real friends, but they do theory. All right. If
Yeah,
you guys
I have a degree in physics.
Yeah.
Theoretical physics.
not a theoretical
Yeah,
degree in
yeah.
physics. Absolutely. All right. If you guys aren't following, click the follow button. We're going to put a prediction up there right now. We use our prediction to ask science questions. Use your standard internet units to bet on this question. Massive elementary particles like an electron are tiny black holes or not tiny black holes? So I'm a chemist. I live in the world of electrons. I've never thought of them as massive elementary particles, but I guess
Yeah,
in the
so-
context of neutrinos and whatnot.
Yeah, so the black holes are made when you have a mass concentrated on a small region. Right, so star collapse and the mass of the star is concentrated on a small region, and they become black hole. Yeah. So elementary particles like electrons are very small, and they have mass. So should they be black holes?
Yeah. So, do you guys think massive elementary particles like electrons are tiny black holes or not black holes? That is that's an intriguing thought. It's massive. I mean, it's localized mass makes a
Yeah, it's
black hole.
elementary particles, so
Get ready.
it's point-like particles. As of today, we have no evidence that electron has some finite radius.
Get ready.
Yeah, as of now.
Cuddle Puppy. Someone bet on something so I can bet the opposite. Cuddle Puppy is one of our regulars, and they like to game the system by betting against whatever the mainstream is. So if they get a payout, it's going to be like 20-1 or whatnot. I'll vote yes just to be contrarian. Let's do it. That's the way we roll on this stream. Let's be skeptical and contrarian. Is your prediction 5 seconds left? All right. Massive elementary particles like electrons are... Take, are they tiny black holes or not tiny black holes?
They are not tiny black holes. I think everybody was able to guess that because I was asking the question.
Oh, it was 3-2, but there was, I think it was contrarian betting. But
Yeah, so if the world was classical, if there was no quantum mechanics, then they would have been black hole.
that's interesting.
Yeah,
The mass is
because-
localized enough to...
Yeah, because according to classical general relativity, if your mass is concentrated in a sufficiently small region, they always become black hole. Right? But thanks to quantum mechanics, they are not black holes, and
Get ready.
so one of the prediction of combining quantum mechanics and relativity is the existence of antiparticles.
Get ready.
And so what happens is that
Get ready. You're doing great.
if you try to measure the position of an electron, then so this I don't know.
Oh,
There are
wow.
no enemies here. I just have to collect.
It's like
It's a bonus stage.
never-ending story dragon here.
Yes,
I
it's
like it.
Definitely inspired by that one.
I like it.
Yeah.
So congratulations to everyone that said not black holes. I mean, what would it
anyway,
look
so,
like if
yeah,
it
so
were?
the reason that the electron is not a black hole is because their positions are not definite. So actually, they are not concentrated. I mean, the electron is not concentrated in a small region because of quantum uncertainty. And so if you try to measure, right? Let's say you have you try to measure the position of the electron using scattering with light or something. Okay, and since you can't measure the position of electron with a precision higher than the wavelength of the light, if you want to measure the position very well, you have to use short wavelength photon. Okay, but shorter wavelength has higher energy. So when the energy of the photon exceeds mass of the electron or twice of the mass of the electron, actually the photon would create electron and anti-electron pair or positron pair.
That's interesting.
So you have the original electron, and you try to measure the position of this original electron, but then light will create a new electron and a positron. So now you don't know which electron you're talking about, right? And there are 3 particles also. So the notion of position of particle is meaningless if your resolution is too high.
Yeah.
Yeah.
That's intriguing.
Yeah. So this uncertainty in position is much bigger than the radius that a black hole would have if the electron became a black hole. So that's why. So this fuzziness in position comes before electron becomes black hole.
What is that thing?
You're doing great.
I don't know. I wasn't paying attention.
No worries. How many stages does this game have?
Maybe 15. I don't know.
It's not bad. What's the farthest you ever made it back in the day?
Maybe 3.
Get ready.
Yeah. So this was an expensive game. So because actually this came with first of all the control was using those airplane controller and thick and stuff like that.
Like 2
and then
joysticks,
and you sit in a seat, and then this whole machine moves based on the motion of the player. So that was sensational.
Yeah.
Yeah. But it was like 150 yen or something. It was very expensive.
Yeah. And you got like 3 lives and got to play for a minute.
And my allowance was maybe 500 yen.
Don't spend it all in one place.
And this music was also shocking.
Get ready.
Before this game, most games had this beeping electronic sound, and this game with a FM synthesis sound chip, and as well as some PCM sound chip with the. So I thought maybe there's a CD player in the inside of the game.
Yeah.
Yeah, but
it actually made some good music. Sir Fink said it wasn't like that in the States. That was the badass Japanese version. Man, if you guys haven't been to Japan, like the arcade scene is absolutely incredible. I mean, they have the like casinos, and then adjacent to them is regularly an arcade.
Yeah.
So I've been to Kyushu and Tokyo, and it's just everywhere. Arcades. It was awesome.
Yeah. It's very different. Yeah. So basically, I don't know. So in the US, analogy would be imagine that in front of every subway station in New York City, there's an arcade. So kids will just go to those places on their way back from school, because we walk to the school. First of all, take bicycle to the school, and just stop by at those places. Yes, in the US version, I think probably they don't know the arcade version, but maybe they know the Sega Genesis version or something, maybe.
Yeah. Well, there's also one for the NES called 3D World Runner that looked a lot like this. Not these good of graphics, but it was running, and yeah. We just had a standard arcade box with a joystick. That's unfortunate. All right, non-dairy neutrino. Taki mentioned he also does cosmology, and definitely not the exact question for my thesis. But how does the Momentum mode occupation of spontaneous particle creation due to inflationary cosmology depend on the time and inflation behavior. In 3D, please. It's already done in 2D. Jeez, that is a mouthful.
I'm trying to understand the question.
Yeah. You want to read it? It's right here. Non-dairy Neutrino is working on their master thesis right now, so I'm assuming it's directly related.
Get ready.
Occupation of spontaneous particle creation
Get ready.
in 3D. So I'm not sure about the 3D, 2D part. I think I can only answer some general things. So this is sort of related to what I do.
Ready.
Is so like let's say somebody asks me what I do, what is most excited, what is the most exciting thing about my research, and I would say I'm studying the vacuum.
Get ready.
And people would think, oh, that's the most boring thing to study because vacuum means it's empty,
Yeah.
right? But actually, vacuum is very, very interesting place. According to, so once you combine quantum mechanics and relativity, vacuum is full of lots of things going on. And for example, the reason that we have mass, like things like electrons have mass, is because of thanks to the nature of our vacuum. If our vacuum was in a different place in a theory space, then electrons would have no mass and there would be no atom. The Bohr radius would be infinite. And similarly, so a little bit closer to what this person is asking about, so black hole actually is not completely black, but it actually radiates, and the radiation is called Hawking radiation, and that is also related to properties of vacuum. So you could define two. So what's interesting about curved space like black hole is that it's not clear how to define vacuum. And for example, you can define vacuum as a vacuum that the observer who's sitting infinitely far away from a black hole sees. So let's say black holes in Andromeda galaxy, and we are here, and then we can define our vacuum, and that's kind of like a normal vacuum. But another interesting vacuum is the vacuum from the viewpoint of a person who is freely falling into the black hole.
Ready.
And then according to general relativity, if you are freely falling, then you don't feel gravitational force. I mean, or more, in a more technical terms, your space looks locally flat in the neighborhood of your position. Anyway, so since from the perspective of this freely falling observer, his space-time around him is locally flat, so like he would just apply the definition of usual vacuum in the flat space, at least locally, right? So there are two definitions of vacuum, and this mismatch of the two vacua causes Hawking radiation. So empty space from one perspective is not an empty space from the other perspective, and that's the basically source of Hawking radiation. And then when and the spontaneous particle creation during the inflation that this question is asking about, that's is very similar to that. So when
Get ready.
definition of vacuum also becomes tricky when Hamiltonian depends on time. So when Hamiltonian is independent time, the vacuum is just the lowest energy state, ground state of the whole universe. But when the Hamiltonian is changing in time, energy is not conserved, and the definition of vacuum also is time dependent, blah blah blah. And that's when things gets very interesting. Yeah. So even when you start with no particle, like zero particles, in the initial vacuum, you may not. in a later time, that vacuum is no longer a vacuum of the new time. So
Get ready.
then you might see particle creation. And actually, we do, and
Get ready.
and there are also like fluctuations of the vacuum during inflation, and then that fluctuation causes a fluctuation in energy density, tiny fluctuations, and but those tiny fluctuations grew and became galaxies and stars and us. So actually, it's very important. Those tiny fluctuations are important.
Non-dairy neutrino. Yep, vacuum choice is a significant part of the paper. I love that there's different definitions of vacuums and how you define them. And yeah.
Yeah, so studying the vacuum is actually very interesting.
Codemaster,
Yeah.
this death sound is getting very old. This is not a trivial level. I'll turn down it a little bit. 'Cause that is,
Yeah, but
it's
I'm sure
louder.
this is the voice of somebody in Sega
Yeah.
recorded.
Like, I mean, they were notorious for like having a janitor record a voice or a comment or something, or naming, like Mario's named after the building manager in the US. Like,
Oh, really?
Yeah, that was fun about Nintendo and early Japanese companies. All right, Codemaster. Dr. Ken's questioned Take's knowledge of hitboxes, and now he realized that Take is the geekiest of all Ask a Scientist gamers. I don't know if that's true. Like Eugene DePrince, he was top 500 in speedrunning Mario, and I think he was top 200 in Mario 2. So we've had a number of super geeky
Geekiest
guests.
in the physics way or geekiest in the
I think
video
in
game way?
video gaming way, I think so. But
Yeah,
we've
but
had-
my knowledge is limited to this period.
yeah.
Yeah,
Oh, no worries. Most of us are.
85 to maybe 90, early 90s.
Yeah, I still play Mario. So I actually played Mario Maker, which is a version of Mario on Switch where you can design levels, things like that, which is pretty fun.
So I was as you can see, I'm an awful player, but I was very into games. Mm-hmm. Yeah.
Oh yeah, but we have Infinite Lives, so let's do it. You're beating this game tonight. We're doing that at the very least. All right, this is like trying to describe high-level physics while being stoned by a crowd of medieval peasants. A brand new sentence has emerged in chat. Thank you. Thank you, Sir Fink. Non-dairy neutrinos following up. And the dimensionality I was talking about is considering the dimension of the momentum space. So previous work has been done to investigate this question with particles in the plane. My project is using high-performance computing to consider 3D
Right.
momentum space.
Yeah, so obviously our world is 3D, but of course, with the limited computation resources, we often go to 2D, sometimes even 1D, and stuff like that. Yeah. So
Well, non-dairy, best of luck with writing your master's thesis, and hope the simulations work out. High-performance computing. I mean, computing power is exponential, right? Versus when you started at FSU versus now. I mean, how much easier is it for you to do calculations?
well, so I'm an old-fashioned theorist, so I mostly work with paper and pencil.
I see you just
Yeah,
derive.
and then I use Mathematica on my laptop. Mm-hmm. But of course, that's not common. I mean, many of my colleagues actually use a full power of a computer to do intense calculations, and which are necessary for interpreting experiments. Because experiments also becoming very, very precise too.
I mean, but to like fit your data to models or fit your model to data, I mean, that takes computational power, or you don't typically do that? Like, do you take a data set and say, does this model fit this data set?
Get ready.
I do, but the so for example, right now I'm in a primordial black hole project I'm working on. Not for the feeding data yet, but we are using my postdoc. I shouldn't say.
Yeah, we don't do anything.
My postdoc is
there we
using
go.
a high performance computing center facility to run.
We get the dragon ride again.
Yeah,
The cat? What is that?
solve Einstein equations. Need to hit these.
It's pretty satisfying.
Yeah.
Absolutely indestructible. All right, so speaking of equations, one of the questions we like to ask all our guests, and particularly relevant to physicists, what's your favorite equation?
So
You're doing great.
physics equation or just equations in general?
Just equation in general.
Yeah, so
any equation.
I think my favorite equation probably e to the I pi equal -1 in mathematics. We use that in physics too, but it's a great synthesis of algebra, geometry, and analysis, right? The calculus. So we need all three subjects. So all three subjects are amalgamated into that equation. So it's just kind of amazing.
Sir Fink, of course, that's your answer.
In physics, all of the fundamental equations in physics are beautiful. Maxwell equation, beautiful.
Yeah.
Einstein equation, of course, beautiful.
Dirac equations.
Dirac equations
Yep.
is also beautiful in a certain way. Actually, it was beautiful, was considered beautiful. I thought it was beautiful. But as I understood quantum field theory more deeply, Dirac equation may be beautiful, but it's actually trivial.
It is now.
Yeah. So if you study a thing called representational Lorentz group, Dirac equation is just expression of that. So in that sense, it's trivial.
That's pretty crazy to think about.
So it doesn't have as much physics content as Maxwell equation, Einstein equations do.
And what is that, 60 years ago? When was Dirac equations?
I think it was around 1928 probably. That's when Dirac.
So, oh God.
Yeah,
90
so
years
quantum
ago.
mechanics was in 25 or 26, and Dirac equation was few years after that, so
Yeah.
maybe 28. And Dirac was like maybe graduate student or something, right? So, yeah, it's pretty encouraging.
Dairy Neutrinos. Thank you, Take, for all the discussion. I think I actually learned something. This is easily one of my favorite Twitch channels. Non-Dairy, thank you for always joining us on stream. It's a pleasure to have you. We love the discussion. We love the questions.
Yeah,
we got a little
thank you for the
technical
questions.
heavy, but I'm glad we could help you out with your master's
Yeah,
thesis.
I can be less technical. I mean, I'm just
Yeah. No. Yeah, it's a very technical
I'm
question.
improvising my answers right now, so, but I can add more content. I mean, more
no worries.
clarification and stuff like that. If it's not clear.
Two nerds, one black hole has a very non-technical. What's the scientific definition of beautiful?
Get ready.
You don't have to answer that, but you can.
There is no scientific definition of beauty.
Yeah.
Yeah, but so it's kind of like there is no. I think there's some American judge, right, like who said there is no definition of pornography, but it's obvious when you see it.
Yeah, you know it when you see it. Yeah.
Yeah, I forget who it was, but it's kind of like that.
Yeah.
Maybe it wasn't good analogy, but I think all good theoretical physicists will agree which equations are beautiful. I mean, we will recognize when
general
when you
consensus.
see it. Yeah, but we cannot define it.
I mean, there are people trying to define beauty, even like faces and things like that. If you
Yeah.
take a sampling and you like,
Right.
what trends are similar? And it's symmetry, but not perfect symmetry. There's some like
I can at least. I can. Yeah, that was brutal.
Yeah.
For me, closest thing to beauty of physical laws in other field is maybe classical music. Well, not any classical music, but like music like Mozart, Beethoven type of era. Not more modern romantic era of music, but if you look at Mozart sonata, the beauty that you feel from Mozart, listening to Mozart sonata, or maybe analyzing Mozart sonata, is very similar to beauty of physics equations. So it's kind of simultaneous presence of robustness and fragility. Is that a word?
Mm-hmm. Yeah. Fragility. Yeah.
Fragility. Yeah.
That's fun.
So, like when you listen to Mozart Sonata, you see that
Get ready.
it's robust in the sense that every note is kind of inevitable. Like every note falls.
Yeah, it's the way it should
Rather
be.
note. I mean, you get the feeling that there's no other way, right? But then simultaneously, I mean, it's very fragile. Or maybe the same thing. It's a flip side of robustness that if you take out any one note, it's just everything falls apart. The physics equation is very similar. I mean, when you look at, say, Maxwell equation or Einstein equation, right? So with some experimental data, as well as some other theoretical input, I mean, you get the sense that there's no other way.
Get ready.
Like Maxwell equation had to be that form, and Einstein equation had to be that form. If you look at at least I get that sense.
Yeah.
So they don't look arbitrarily to me. It has to be that way. But then, at the same time, it's very fragile. If something was a little bit different, and it completely. So let's say experimental data is a little bit different, right? Then you cannot fit this deviation by modifying Maxwell equation just a little bit. The structure is so rigid that
Falls apart.
just falls apart.
Yeah.
So it's a very similar. So in that way, it is beautiful.
So Uncle Bill followed up. I was tempted to say elegant, but that's just replacing one word for another is hard to define. True. I mean, I like the word elegant to describe a lot of science. It's just like flowing, and it's just like you described the way it should be. But I think Sir Fink wins the smart nerd joke. What about semi-classical music? No.
Semi-classical. That's a very nerdy joke.
Yeah, no, that's too far. You win the award of biggest nerd on this nerd stream. Beauty is an observation, and it's in the eye of a beholder. No question about that. Matt isn't a robot. Welcome back to the stream.
Yeah.
Good to have you.
Yeah, maybe I can say a little more. For example, like Newton's law of gravitation, the force goes like 1 over r squared. And this could have been 1 over r cubed. I mean, there is no, besides experimental data, there is no compelling reason that it has to be 1 over r squared. Could be maybe 1 over r to the 2.1 or something, right? Or 2.0001, whatever. But according to Einstein's theory of relativity, has to be 1 over r squared. And if the motion of planets suggests that it should be a 1 over r to this 2.00001, then the entire general relativity collapses. So there's this fragility to it, but at the same time, it's very robust because you can confidently say has to be exactly 1 over r squared.
All right, we're about an hour and a half in. Anyone just joining us, Ask a Scientist Gaming Expert, Mediocre Gameplay Expert Science. My guest today is Take Okui. He's an expert in theoretical particle physics, talking about all sorts of calculations regarding fundamental rules that govern the universe and the physics behind it. And he's interested in everything from monopoles to primordial black holes to whatever it might be, using non-standard models to describe physics of the universe and whatnot. So yeah, if you have any questions about particle physics, Take is happy to answer those questions. Beautiful equals minimal number of leaves in the expression tree. That is an interesting take. That's an interesting framing. The beauty in equations is kind of like glass. Glass is strong, but it collapses with the smallest of cracks. That's fair. Does not flow like water, that's for sure. Hey, Codemaster, I want you to go back to the YouTube video after this and find out how many times Take has died in this game and translate that to dollar number and comment on the YouTube channel. Because this is hard. Is it exactly the same every time, or is there a lot of randomness in this game?
I think there are many. I mean, usually the games from this period that doesn't have much randomness. Yeah. actually, because working out perfect strategy was part of the fun.
Yeah,
Yeah,
there's a path.
yeah.
Yeah, that's one of the things I like about video games.
Yeah, people
'cause-
would exchange information in arcade gameplays. So there's a safe spot here and stuff. I mean, there was no internet.
Yeah.
Right. So all the information exchange was done in real time in real place, or maybe through magazines or something. But magazine was maybe once a month. Was not mostly word of mouth kind of thing.
Yeah.
Yeah.
No, I mean, that still exists now, but it's much more communicative through the internet. People figuring, I'm sure there's someone on Twitch playing this right now, trying to speed run it or do it as fast as possible, or do a deathless run of Space Harrier. It's the glory of a million monkeys playing video games. Somebody's good at this somewhere
Well,
in the
of
world.
course. I'm terrible at this.
Non-dairy neutrino, the default metric with Mathematica uses its simplify function. That's fun. Information exchange is done on the playground. Yes, absolutely. Your son has insisted that whatever your dollar amount comes to, that should be his allowance. However many deaths you had in this game.
That's I don't know how many. Did he count how many times I died?
No, I told him he should go back to the
Maybe,
YouTube video
yeah,
after
1
this and
cent
figure
per
out.
life. Yeah.
Order. We'll do arcade numbers. All right. Before we go into the technical questions, which we have a couple lined up. So earlier we talked about Big Bang Theory, about getting some of the physics right and wrong. I mean, besides Big Bang Theory, are there movies or TV shows that you've watched and you're like, well, they did their homework, they got the physics right, or they got it completely wrong and it's a disaster?
Well, so there's a movie called Interstellar, and actually I have not watched this movie, so actually I cannot. I don't have any my own judgment about this, but I heard that the
black hole simulation.
general relativist in Caltech called Kip Thorne, he was a scientific consultant for this movie, and he's a serious guy, and he did his best to make this movie scientifically accurate. So, but I have not watched it myself, so I don't know. But among the things I watched, I mean, mostly. I mean, I don't even expect that they get things right. Right. I mean, even when New York Times try to describe some physics discovery, I mean, it's not. I mean, it's vaguely correct, but not completely right.
Yeah.
I mean,
can't be for a general
the
audience,
typical
right?
movie like Star Wars. In Star Wars, they say force is energy of the universe or something. I mean, the force is not energy, right? I mean, they don't even have the same units. I mean, force is in Newton and energy is in joule, right? So, I mean, the force is not energy. So, in that level, right? So, yeah. So, like when they, I mean, a lot of movie talk about goes fast and time dilation with special relativity. All those stuff is not right.
Yeah.
Yeah.
No, they have.
I mean, I don't even expect.
I mean, they've discovered something magical that breaks the rules, which may or may not happen. It happens regularly. I mean, new physics comes into play and we come up with nuclear bombs and nuclear power. So who knows what's possible?
Get ready.
The Codemaster follow-up. So do you think sci-fi movies were ruined from your understanding of science, or do you think the small details that you are right enhance the experience?
Sorry, what was the question?
Do you think that sci-fi movies have ruined your do you think sci-fi movies were ruined from your understanding of science, or do you think the small details that were right enhance the experience? I mean,
Ruined?
ruined as in made it unbearable to watch, or
No. I mean, I enjoy watching Harry Potter. I mean, the scientific accuracy is not my criterion for enjoying movies. Yeah.
but sometimes they get it so bad it's hard to
Yeah, actually, if they pretend to be scientifically accurate, and if they are not, I may get upset. Yeah.
yeah.
But Star Wars doesn't try, right? I mean, I don't. It's even questionable whether it's sci-fi or not. Maybe it's not sci-fi.
Yeah, I've said that before on this stream. Is one of my criteria is like, if they just say, if you abandon this one rule, all this makes sense and it's okay. It's easier to suspend belief if they just say a warp drive exists and they don't try to justify it with actual physics. Just say you can do this.
Yeah, that's actually better. Yeah, I mean, for example, in the world of sci-fi, I mean, time travel kind of thing is taken for granted, right?
Yeah.
They don't even try to justify.
It's true.
And I think that's okay.
Yeah.
If they started saying negative energy and stuff like crap like that, and actually that's annoying. Actually.
Yeah. 1.21 gigawatts. Yes, gigawatts.
Back to the Future.
Yeah, exactly. Star Wars is fantasy.
I love
laser
Back to the
swords.
Future.
Yeah. No, absolutely.
That's one of my favorite.
I think they do time travel right. That's for sure. Man, that's a fun one. We should probably do another prediction. Which one do you want to go with?
Get ready.
Did I see?
Sorry. Yep. That's less.
Okay, maybe I can do the
Get ready.
Last one?
last one. Maybe.
All right. We'll do another prediction, ladies and gentlemen. Non-dairy neutrino. What do you mean? Obviously, we just need to make the inverse tachyon beams converge. I love it. It's like a Mad Libs of scientific terms. It's
Yeah, I think tachyon is kind of a standard term in sci-fi world.
yeah. No, it's
So
catch-all, right?
actually, I'm okay with that.
Yeah. Star Wars is a space opera, not sci-fi. That's fair.
Yeah, that's fair.
Ditto to a slightly lesser degree for Star Trek. Star Trek is like a philosophy delivery mechanism, like exploring human behavior and rights and wrongs, and especially Next Generation. Across the Streams, Ghostbusters, classic.
Yeah.
All right, we're going to put another prediction up there. If you're not following, click the follow button. Your 300 standard NRE units. Bet them on this question. We're going to ask a science question, and you guys should gamble according to your confidence. The question is, the Higgs boson gives mass to atoms. True or false? Is the Higgs boson what gives mass to atoms? Again, note you're on Ask a Scientist Gaming Honor Code, so you can't look this up on Google or ChatGPT. Instead, you have to actually guess the answer correctly, or
Look in a textbook.
or look in a textbook.
Is it allowed?
You can
or
find this in a textbook in 2 minutes. We will give you the credit for it.
Oh, that's fair. Yeah.
All right. So Take, I know we've been drinking that sake, but when I went to, so I asked Take to give me suggestions for sake I should pick up, and he suggested the Nagori that we've been drinking. They also had this, a can of Soto sake.
I don't know. That
Premium
looks like-
Jumanji. I was intrigued, so they had this on the shelf next to the bottle that we haven't drank. It's a can that you pop open the top. This might be cooking sake. I have
is
no
that
idea.
really legit?
What's that?
It's not a methyl alcohol or something.
There's.
Is it ethyl alcohol?
I think it's okay. It was
Okay.
in the sake section, so we're gonna give it a shot. All right, you guys have about 45 seconds. Higgs boson gives mass to atoms. True or false? Wow,
Get ready.
it came in a can. Are you up for this?
Sure.
You want me to try it first, just in case I go blind?
Get ready.
I think we'll be okay.
Get ready.
I hope this is good. If not, we can dump it out. We'll give it a try. But yeah, here's the can we had. Whole Foods selling sake. How was it?
That's kind of
Get
this
ready.
strange flavor to it.
It really does, doesn't it?
Yeah.
It's got a Romany.
Get ready.
The phrasing of that prediction is tricky. That's fair. We only have 42 characters, so I have to cut down after they send me them, so I apologize if the meaning was lost. All right, Take. The Higgs boson gives mass to atoms. True or false?
False.
False.
Yeah.
Wow, this
So
is
if you
dark
read
horse
New York
bet.
Times articles about Higgs boson discovery, stuff like that, they was what they say is that the scientists, physicists have discovered the origin of mass. Blah blah blah. So it is true that for example, so atom is made of nucleus and electron, and it is true that Higgs boson give mass to the electrons, but not to the protons and neutrons. I mean, they do a little bit, but only like
Get ready.
less than 1%. And The reason is a little bit technical, but the most of the mass of the protons and neutrons come from E equal mc square, or I would say m equal E over c square. So the inside of protons and neutrons, there's a strong binding energy kind of thing. Right? So protons and neutrons are made of quarks, but quarks weigh only about they weigh less than 1% of the total mass of the proton. The rest is just binding energy converted to mass because of the m equal E over c square relation.
All right, congratulations to those of you that said false.
Most of outer mass just come from energy, binding energy of quarks.
Congratulations to those that said false. You got a 16-1 payout. The dark horse bet won on this one. So in terms of betting amounts, 94% said true, 6%
probably
said false.
internet will get it wrong, right? Because they just look up for a New York Times article or something. Yeah.
A podcast named Daniel and Jorg Explain the Universe gave me the answer just last week. Are you familiar with that podcast? I don't know who that is. Daniel and Jorg.
Daniel and
Jorg. Jorg?
No.
Jorg? No, it depends on the origin of that. Explain the Universe. Out of UC Irvine.
Daniel Whiteson. Yeah, I know him. Yeah. I've
George
met him
Cham?
once.
I'm going to say it's George, based on being Cham.
Yeah, so he is an experimentalist at the LHC, Large Hadron Collider. Yeah.
That's pretty fun. And they were discussing this last week. What are the odds of that? That's pretty spectacular.
Get ready.
That last question seems like a chat GPT fail type. Well, it does have access to the internet now and the New York Times, so probably. Man, I do not like the sake as much as the Nagori.
You do like?
I like this one much more than the soda one. We tried it out of a can. It did not deliver. Thank you for placating me on that one. All right.
I don't know what Soto is.
I no idea. I mean, there's some Japanese writing on it. I don't know if that gives you any insights. So it's really small.
Get ready.
No, it's not Japanese, it's Chinese.
What?
Well, okay. Well, there's a Japanese word, but it just said gluten-free. Gluten-free alcohol. That's great.
Seems so authentic.
Yeah.
That's awesome. This was just made in somebody's basement in Tallahassee. They just put it on the shelf, is what we learned. All right. Anyone just joining us, Ask a Scientist Gaming Mediocre Gameplay Expert Science. Our guest today, Taki Okui. Sorry, I wanted to get your last name right. He's an expert in theoretical particle physics. He's happy to answer your questions about theoretical physics, particle physics, neutrinos, talking about primordial black holes, magnetic monopoles, whatever the journey takes us, we're happy to talk about them. Speaking of which, we have to catch up on a few questions. Uncle Bill asked, I've heard the inverse square law given as proof that the universe does not contain more dimensions than the space-time we can perceive. Have you ever heard of that?
Yes.
Can you explain?
This 1 over r square part is 1 over r square if the space has 3 dimensions. If the space was 4 dimension, then it would be 1 over r cubed. I mean, if I take the same fundamental equations and solve it. So, well, if there's a physics students listening to this, and then what I'm saying that if you solve Laplace equation or Poisson equation in higher dimensions, then the power will be higher. Just using Gauss's law in higher dimensions. Anyway, so we do know that the question is, how well do we know it's 1 over r square? So we know damn well that it's 1 over r square at large distances like solar system and stuff like that. But once we start looking at things at distances smaller than about tens of micron, then we don't have any direct experimental evidence that the force between two masses is 1 over square. Okay, so the down to 10 or 20 micron, we have tested that the force between two masses goes like 1 over square. But there is no, but we don't know anything about the force below that distance. An experimental challenge here is that the so gravity is extremely weak force, okay, and as you can see that your muscle can lift mass even though there's a gravitational force between the mass and then the entire Earth, right? So gravity is actually very, very weak force. And so it's very difficult to measure gravitational force between two objects when the distance between them is very, very small, because any little things like that could just disturb the experiments completely. So that's why we don't have anything below tens of micron. Yeah, so it is possible that maybe there's more than 3 dimensions at smaller distance scales. So if the 4th dimension or 5th dimension is smaller than
Cuddle Puppy, I have no mechanism to give you channel points. I'm sorry. Sorry to interrupt.
If the extra dimensions are smaller than, if the radius of the extra dimension is smaller than, so imagine that imagine a long cylinder, okay, infinitely long cylinder, and this long direction represents our 3 spatial dimensions, infinitely large spatial dimensions, and this tiny radial direction is, say, the extra dimension, like 5th dimension or 6th dimension, right? So if this tiny radius is less than micron, tens of micron, then it is experimentally allowed. So they could be there. Yeah.
Dude, so I just looked it up. 18. There are 18 levels in this game, so presumably this is the last boss.
Yeah, I think I'm not paying attention, but I feel like I'm beating the bosses again. So I think all the bosses came back, and I think I'm just fighting with all the bosses again in the last stage, and then I think so this is the last one.
All right. It's hard though. He's shooting fast. And that's why I include macro as a parenthetical.
And
yes, I did not capture that.
Probably you can't. I mean, you cannot tell this, but this control is very, very unique.
Yeah.
So if I just let it go, then they just move. No. So it's not easy to control.
Well, it's like it's on a rail type game, right? Where it's moving you through space and it's shifting you, and you have to fight it. It's weird. It took me a while to set the controls in a reasonable way because I didn't know what keys to do on that.
Oh, so I don't have infinite life. I only have 2 left.
I'll give you more. There you go.
Wow,
that's free lives.
That's amazing.
Yeah, and then it snaps back to the center.
This dragon is very...
Yeah, it's destroying you. When chat comments on your gameplay, you know it's gone too far. I mean, it's a couple shots here and there, right?
Yeah, it's getting redder and redder. So...
Was that the key? It's just slowly hit him over time. I hate when they don't have boss hitbox or hit bars, like how many shots are left, but maybe that was before.
Oh.
Ugh, that sake was a mistake. Don't drink it. Don't drink Soto. You don't have to drink it if you don't want to. I can pour it out.
Yeah, I will.
Oh, there it is. The end.
The end.
Congratulations. We did it, ladies and gentlemen. Good game. You beat it. High score. You can put your initials in. Now it doesn't matter. Now you ride the monster from Neverending Story. All right. Congratulations.
Thank you.
A lifelong goal has been fulfilled.
You
beat Space Harrier. Is it everything you hoped it would be? It's so tragic. It just says the end. There's no like end scene. There's no celebration. It's just the end.
There's an ending music.
Yeah.
Yeah.
Oh, is that going on right now? I can't.
No, not.
All right. What do you want to do next? So you played Salamander, Space Harrier. Other ones we have Load Runner, Puyo Puyo, Solomon's Key for the NES.
Oh, let's play Solomon's Key.
Solomon's Key. We're going to jump to the Nintendo. All right. Let's do Talking Heads while I shift this. So that will be the Nintendo controller. And do you want cheats active on this?
No,
I can give you infinite lives.
maybe Infinite Lives.
Okay. There's a couple others, but... All right, ladies and gentlemen, we
Well,
are
it's
jumping to Solomon's Key.
Different.
From the version you played?
No. I mean, it's the same. It's just well, I need to remember how to conclude. Wait. This is not me.
No,
It's
press
a demo.
start. Yep, start
I
again.
thought I pressed start. No. What I'm saying is different is that the so jump is up instead of a button.
Yeah, Codemaster, we do have Fantasy Zone. So we can visit that one a little bit. We're at 9:50, so we have about an hour and 10 minutes left. Somewhere around 10:30, we switch over to NARC. Man, do you want me to dump out this sake? You do not have to drink this. I'll rinse it out. Should probably give you a question before I leave.
The reason I said this looks different is because in the old days it was a CRT monitor, right?
Yeah, this is
And it
higher.
was a lot fuzzier than this, so that it's kind of strange that I can see every single pixel.
Yep. No, it looks worse for
yeah.
some reason because it's not as blurry. All right. Matt isn't a robot. Last time I was here, I asked quantum entanglement could be used to better communication to track time. That's interesting. Could quantum entanglement be used to better communicate to track time?
Track time. I mean, to build better clocks.
Yeah, I mean, now they use vibration of crystals most of the time, right? That's the best cesium crystals, but can quantum entanglement be used?
I'm not sure whether quantum mechanics could help building better clocks. I mean, I never thought about that. Yeah, I don't know. No, it's not obvious to me that it could help, but it's also obvious. It's not obvious that it does not help. Yeah, can you be more specific about what's a possible example of mechanism for? Oops. If you can give me some concrete mechanism or something, maybe I can answer your question.
I'm back. So I've never played Solomon's Key. This is a puzzle game plus...
Yeah, it's kind of a puzzle game. So to think, so this is like a fireball and it's indestructible. But once I destroy this block, it's gonna chase me. So you have to think about what to do.
Not sure if this is a question. Is this a much better game for physics talk? Is it easier to focus playing this or while playing
So you went that
Space
way.
Harrier?
Okay. Yeah, maybe this is actually worse. I need to think about it.
That's awesome. All right. Sir Fink asked, I've talked...
Shuro was maybe better. Oh, it came back. Okay.
You have infinite lives. I've asked Taki about this before, but can you talk about why we know that local conservation of information prohibits teleportation?
Local conservation of information.
Yeah, so this is an entropy thing.
Uh, he said he asked that question to me before.
Yes,
I
you
don't
talked
remember
about it
that
before.
question.
Why we know local conservation of information prohibits teleportation.
I don't know what you mean by local conservation of information. I'm familiar with local conservation of energy and momentum and stuff like that. Conservation of local conservation of information. I don't know what that means. Because for me, information is not localized. No? I mean, there's no place where information lives. So I'm not sure what that means by local conservation of information.
Nope, I gotta change our game. We are on to Solomon's Key.
Oh, I wasn't paying attention.
It's clearly people are coming to the stream for the video gaming, so we want to make sure they're coming for the right video game. All right, if you guys have questions for Take on theoretical particle physics, throw them in chat. He's happy to answer them.
Yeah.
Speaking of questions, there was one.
Yeah. So to tell me how to define what local
information
is.
I mean, I know in information, like we talk about entropy a lot in chemistry in terms of like the statistical definition of it, but sometimes it's defined in the scope of information.
Yeah, so if that means entropy density.
Yeah, that would be my guess.
Okay.
All right, do you want to keep going on this, or do you want to try one of the Sapporo or...
Yeah, let me go Sapporo.
Okay, sounds good.
Just for a change.
I mean, you have the option. Kirin or Sapporo?
Oh, okay. I'm gonna go... Let me go Sapporo because that was near my university.
That's true. Yeah. It's famous. Where's my bottle opener? There we go. Take, you're losing lives as you talk. Your son is upset with your gameplay.
Well, life means time.
Yeah.
There's a time for this game. Yeah, I forgot about that.
Keep in mind, we've been drinking alcohol while talking science, while playing video games.
Yeah, it's too much multitasking.
Yeah, it's underappreciated until you have to actually do that, how hard it actually is. But this did give me a newfound appreciation for Twitch streamers that are
I'm learning. You see, I made a wall.
Ah, that's good. Like the Twitch streamers who are at the top of their game that...
Oh, I didn't remember he could do that.
Yeah. All right, Uncle Bill said, I've been curious about accretion disks of actively feeding black holes. With so much material piling up and heating up, does any of it ever reach energy pressures for fusion? Oh, that's interesting. Can you get fusion at the accretion disk of a black hole?
I don't know, but I would say yes. Because there's so much, I mean, things that go on around black hole could be really energetic. So I would say yes, but that's just my guess. Yeah.
And presumably somebody's modeled that behavior, but no one has tested it yet, so... The
Great thing about NES that you can pause game.
You can strategize.
Yeah.
You know, modern strategy games would make this a black screen on the pause, but not this one. Cuddle Puppy. The trick to being a top-tier gamer while streaming is to unconditionally loathe Twitch chat. That's true. The most popular streamers do hate their chat and have zero respect for their audience. That is absolutely true. Not here on Ask a Scientist Gaming. We love our audience. Thank you for joining us.
Please remember that the main thing is physics, not the game.
Yeah, exactly. Mediocre gameplay. It's in our tagline. No one expects anything from us. Uncle Bill followed up. Yeah, I was thinking the X-ray emissions indicate huge energies even if the pressures are substellar. So there's X-ray emission out of the accretion disk of black holes. Is that correct?
Sorry, I wasn't listening. Now I was playing the game.
No worries.
because I was focusing on the motion of this blue.
No, that was good. You jumped him. That was beautiful.
To go over there.
So talking about the high energetics at the accretion disk of black holes, there's X-ray emission from those accretion disks. Is that correct?
Yes. Yeah, there's a violent X-ray, gamma ray emissions from those. Those are very, very complicated thing.
Mm-hmm.
Yeah. So in my research, I'm not an astrophysicist, but I do a cosmology. So to characterize what I do, I think it's one way to characterize my research direction is I do simple things.
Mm-hmm.
So since because I don't use computer simulation very much, I cannot analyze very complicated phenomenon, and I try to do things with just paper and pencil and Mathematica. So things like accretion disk and X-ray emission and stuff like that is not something I am capable of doing.
Mm-hmm.
Instead, so for example, in the context of cosmology, kind of thing. So I can give an example of kind of thing I do in cosmology. So one example is dark matter model building. So like I basically try to associate dark matter particle with some other puzzles that I want to solve in particle physics or cosmology. And so
Nice.
focus is on the. So what I do is that first I solve whatever the puzzle that I'm interested in. For example, let's say what is the origin of masses or like stuff like that, okay? Or why there's more matter than antimatter, right? So there are fundamental puzzles like that, and then I try to solve those puzzles, one of those puzzles at least, and then see whether there's a bonus with my model, and often there is. So like trying to solve say why there's more matter than antimatter, I find that there's a particle that is neutral particle that is stable in my model. Just I didn't ask for it, but there is, right? Then that neutral particle with no neutral stable particle could be dark matter. So I would calculate, but for it to be a dark matter, they has to exist in the right amount in this universe, right? If there is too little, then of course it cannot do its job, and if it's if there's too much, then universe would just crunch. So I would calculate how much I would calculate abundance with of this new particle in my model, and if I find the right amount, I would say yay. If I don't find it right amount, then I would if it's too much, then I would basically give up my model. My model is excluded, right, by data. If there's too little, then I would just say, okay, so unfortunately this can't be dark matter. Dark matter must be something else. So what was I forgot the original context of this thing.
I honestly don't remember the question. I was looking at my other list of questions. I apologize. We went from accretion disks on black holes to...
Right.
Yeah, your models aren't... The way you address these problems wouldn't necessarily answer that question.
So...
Yeah.
Yeah, this game requires too much thinking. I was talking better when I was playing shooter.
Yeah, no, you're trying to focus on this. Well, this one's hard because you have to like think about it and execute simultaneously. It's non-trivial. Do you want to switch to something else? We can try Load Runner or Puyo Puyo.
Puyo Puyo requires some thinking, so I think low runner is probably okay.
Yeah, and we can give you infinite lives in that one too. So let's try Load Runner, ladies and gentlemen. Your son giving you a hard time about dying. You should have him play a video game and ask him science questions while he's playing.
Oh, that's good.
just give him a taste for what this is really like. All right, so one of our standard questions we like to ask, if you had unlimited budget, I mean, you're a theorist, but obviously there are certain data sets you'd love to see or certain information you'd like to gain from experiments. Unlimited budget, no moral qualms. You could do any experiment you wanted or get any data you wanted. What would you go for? What would be your...
Yeah, so unlimited resources, right?
Yep, yeah.
Yeah, so then I would like to build a super hyper uber collider, much bigger than LHC, with a super hyper uber high resolution detectors. Yeah.
Commit to...
Yeah.
I mean, every time they build a new particle accelerator, it's at least 10 times better than the previous one, right? Or something like that.
Yeah.
So the question is, how far could you push it if you had an unlimited budget?
Well, there is no theoretical limit, right? So if I have an unlimited budget, yeah, I could push as much as I want. So that would be, yeah, that would be my answer. Just biggest collider ever. Yeah.
Your son's reply, I'd probably go completely silent, mediocre science with quality gameplay. Those are the two contrasts we have on Ask a Scientist Gaming. We have people that focus on the science and don't play the game, and we have others that focus on the game and don't talk science. And we experience both at the same time. So,
yeah, remember, the game is in the background.
Yeah, exactly.
Not the other way around.
The quality of conversation is what the audience comes for. Speaking of which, if you guys have questions for Take on particle physics, on magnetic monopoles, on primordial black holes, or anything related to particle physics, he is happy to answer those questions.
Yeah.
Complete silence is expert level philosophy. Absolutely. Let's get philosophical here. So Load Runner is a classic game. This goes way back to the earliest gaming.
Yes. But this is not the original.
Yep,
The
this
original
is the
is
Nintendo
in
version.
Apple II or something. So original version is easier to play because you have the view of entire field without scrolling.
Yeah.
This is actually difficult because you don't have the view, so you don't know where the enemies are, and it suddenly appears like this.
And you can kill them, right? If the hole falls on them. Oh, like one of these guys. There he goes. Yep. Do they respawn after they die?
Yeah, they respawn by...
Ooh, non-dairy neutrino is a fun one.
They catch me? Okay, they don't catch me.
Whoa. Oh, nice. Veteran move. Non-dairy neutrino wants to know, what's your favorite particle?
My favorite particle?
Have you ever been asked your favorite particle before?
No, I never even thought about that. I mean, I don't have any particular...
Take loves all of them equally. You have a few favorites. You have a couple favorites you'd list?
Okay, so let me say the Higgs boson, because that's the particle I love and I hate, I would say, because it's nice in a sense that it's the last particle of the standard model to be discovered, and then I sort of witnessed discovery. The discovery happened in my lifetime in 2012, which was very nice. It was very emotional to. I mean, I wasn't at CERN, but I was at Fermilab.
Veteran move. Well done.
I was at the Fermilab watching live streaming of the discovery presentation.
Wow.
And it was very emotional. I mean, we gave, so it was 2 a.m. in the Fermi in Chicago, right? And then we were all at the conference room inside a lab. Some people wearing pajamas, right, listening to the talk, and then after the talk, we all stood up and then just gave standing ovation, even though it was a remote talk. Remote talk before pandemic, it's a different. I mean, remote talk was not the normal thing.
Yeah, it was just so important.
Yeah, so in that way, I like it. I like the. I mean, I have a special memory of Higgs boson, and it was too late. Wanted to go through that before.
Nothing is more...
So
Oh, go ahead.
Before discovering Higgs boson, I published many papers. Some of them with Higgs boson, some of them without Higgs boson. When there was a possibility that Higgs boson does not exist and some other mechanism might be operating. And actually, one of my best cited paper is about it's a model without Higgs boson. And of course, that paper we buried in a graveyard after Higgs boson was discovered. Right? Because,
yeah, we were wrong, and it happened.
Yeah, so that's science in action, right? Anyway, so I thought about many different possibilities, and I always wondered: is there Higgs boson? There is no Higgs boson. And I kind of, after struggling to build a viable model without Higgs boson so many years, I kind of knew that Higgs boson had to be there, because it was very difficult without it.
Yeah.
And it was really had a big psychological impact on me to finally actually see the Higgs boson, and of course to measure the mass and then properties. To get rid of this one, the other possibility was very psychologically big for me.
So follow up on that. Does it annoy you when they call the Higgs boson the God particle?
Yeah, it completely annoys me.
Okay.
Has nothing to do with God.
Well, the story is it was the goddamn particle, right? Because they couldn't find it, and that just got adopted to the God particle.
Yeah, editor didn't like it.
Yeah. The goddamn particle. I love
There are
it.
a couple of stories about these, naming. Oh, I made a mistake.
Yeah.
Yeah, so in my quantum field theory calculations, I draw lots of Feynman diagrams, and then those are the diagrams that represents. Actually each diagram is a mathematical formula. Anyway, and then they are related to particle reactions in a scattering experiment. Do I have enough time?
Yep. What?
Why did
that fall?
I don't understand. Yeah.
So Cuddle Puppy has a gaming comment. Nothing is more humiliating than trying to punch a guy and he deletes the floor below you and uses you as a step stool. Absolutely, this is the most insulting of video games. All right, a follow-up. What's your least favorite particle?
Yeah, so maybe Higgs boson. Yeah, so it's a particle I love the most. It's another hate thing. Yeah,
that is the perfect answer.
Because it just leads to maybe it's most exciting particle because it leaves so many questions unanswered. So it's like the simplest possibility among all possibilities, and then it doesn't do anything else. So it gives mass to electron and stuff like that, right? Like I was saying.
Oof, that was a hard spot.
But it doesn't do anything else, and it's not obviously related to dark matter. It's not obviously related to why there's more matter than antimatter. It just does not answer any other questions. So in that sense, it's exciting because we have lots of research to do. But it's also, you could also say it's frustrating.
Yeah. That's fun. All right, we're running out of time. We should do another prediction.
Okay.
Which one do you want? I think you can pause this, right? Maybe?
Okay.
Yeah, there you go.
Maybe Isaac Newton?
Yeah, that's a fun one. All right, we're going to do another prediction, ladies and gentlemen. If you're not following us, click the follow button, get your standard internet units, gamble them on science questions. How confident are you in the answer? How certain are you that you know the answer to this science question related to Take's research or related to his interests? The question is, Isaac Newton thought light was a wave or a particle. Which one did Isaac Newton think?
It's not a science question, actually. It's a history question.
It's history, but like history of science, we count it. So Isaac Newton
I will follow up on that scientifically.
Absolutely. Isaac Newton thought light was a wave or a particle. Note, you are on Ask a Scientist Gaming Honor Code. You can't look up the answer, just use the knowledge you have and the confidence you have to bet as many points as you want. If you haven't done this before, there's a predict button at the top of your chat right now. Click that button, bet your standard internet units. If you're not following us, click follow. 1, that helps the visibility of the channel, but 2, it gives you more internet points to gamble depending on your degree of confidence in this question. So, did Isaac Newton think light was a wave or a particle?
So this prediction thing, do they get money if they...
No, there's like, there's standard internet. We call them standard internet units. They're imagined internet points. And they can use it to make us take a drink or they can request a factoid. It's basically just internal channel points that don't mean anything at all. Except pride. It's worth a lot of pride. So you guys should answer this question right or wrong, depending on your degree of confidence. And so, yeah, they accumulate these points by getting questions right, but also just watching the channel, they get additional points. And so it's like just feeding into the, I don't know, serotonin gambling addiction kind of center of the brain. Nice. All right, you guys have about 30 seconds. Did Isaac Newton think light was particles or waves? Which is a really intriguing, time period of early science, where nothing was really known well.
One more pile of load. Ooh! Ow! This scrolling thing's annoying.
Yeah, no, I apologize. Take asked for the Apple IIe version, but the video quality and the controls were not great, so I kind of avoided it, but I'm sorry.
There are many ports. So actually, the version I played was on a computer called PC98 in Japan.
Oh, I didn't know that.
Yeah, so it's made by a Japanese company called NEC. And... Oh, why do I go down when I do that?
I don't know.
Maybe that's the feature of NES version.
Yeah, it might be glitch in the floor. All right, Taki, what's the answer? Isaac Newton thought light was a wave or a particle?
Particles.
Thought they were particles. Congratulations for those of you that said particles. Relatively confident you got a 1.33 to 1 payout. So congratulations.
Yeah, so the... if you use experimental evidence available at that time of Newton, it's obviously waves. And basically, many people, almost everybody, Newton was minority thinking it was particle. For him, he loved particles because Newton's law of motion was the motion of particles, and so he wanted to push that viewpoint, I guess. That everything is made of particles.
Nice move.
But, like I said, experimental evidence available at that time was already showing a lot of phenomena that are characteristic of waves, like interference and diffraction and stuff like that. There's things called Newton's ring, right? That's a different interference pattern.
Just
has
wave
his name on it, right?
Yeah.
He knew it, obviously.
Yep.
So to explain interference pattern, he had to say, using his particle picture, he had said that particles sometimes get reflected and sometimes, yes.
I don't know.
I
apologize. That's complete bullshit. That shouldn't have happened, ladies and gentlemen.
So in Newton's ring, there are two reflection surfaces, and wave partially gets reflected for surface, and the wave partially reflected from the second surface, and those two waves interfere and then make pattern. But then Newton had to say that the light particle sometimes gets reflected from the first surface, and sometimes it does not get reflected from first surface and get reflected from a second surface, blah blah blah, right? So he introduced sort of a probabilistic viewpoint.
Oh, that was brutal. Thought you had that.
Yeah. So, of course, there was no quantum mechanics at that time, but this probabilistic interpretation of light sometimes gets reflected and not sometimes not. It's not totally unlike quantum mechanics. You know, it's very very naive, but it's not completely false. So I thought it was very interesting to that Newton had that kind of yeah.
I love Newton because like a lot of brilliant contribution inventing calculus and Newtonian laws, but also a bit of a lunatic sticking needles in his eyes and all sorts of like remaining a virgin because it would keep his intellect high, and like he had a lot of crazy things on the side, but those aren't talked about as much. So
and I think there was more papers on Bible study than the physics. So he has that aspect too.
Yeah.
Yeah.
He was asking big questions, and some of it was crazy.
Maybe I.
Yeah. Newton was a brilliant scientist, but not a good person. That's a fair summary.
Oh, there are a lot of scientists like that.
Yeah.
That's not unique to Newton. Brilliant scientists, but asshole. Yeah, they exist.
Oh, Lori, welcome back to the stream. What's the drink of choice this evening? We've journeyed through a few different drinks where we started with this Nagori sake. It's an unfiltered sake, silky mild is what they describe it as. It was really good. Then we've moved on to Sapporo. So our guest today is Take. He's Japanese, and so I requested him to think of a unique drink we could drink from Japan. So he suggested these two. So
yeah. But the problem is that I was in Japan only for undergraduate.
Yeah.
So of course I only know cheap drinks.
That's fair.
Because I was undergraduate.
No, that's fair.
You know, my goal was more like to get drunk rather than enjoy the drink.
Mission accomplished tonight. I'm pretty buzzed at this point.
I think this is the last one.
All right, Surfing, thank you for joining us. It's a pleasure to have you on stream. Thank you for the questions. You're going to miss out. Take's going to take on NARC, the bargain bin game for the NES, where I have every single guest speedrun NARC at the end of the night. So that'll happen in about 8 minutes.
Oh, okay.
So is there anything else you want to play in the last 10 minutes or so before we take on NARC?
So, how about Fantasy Zone? Is that difficult?
No, we can do that. Let me put this back. Let's get rid of this guy. Fantasy Zone. We can do that. Assuming this computer didn't go to sleep. You've convinced me to get some beer at the store after we're done. That is not the intent of this stream, but feel free. Cheers on us. All right, we're going to move to Fantasy Zone. This is another classic arcade.
Another classic arcade from the same period.
It's from Sega. All right, we're going to get a whole bunch of credits, and let's do it. All right, so this is another one from your childhood. This is arcade.
Yeah.
That controller, sorry. Yeah, we're jumping through 3 controllers, ladies and gentlemen. Nintendo, Super Nintendo, as well as an Xbox 360 for the arcade gameplay.
How do I shoot this thing?
Creative lubricant and social lubricant. We'll say that as well. Oh, that's fun. Lori visited Kyoto for 9 days during her undergrad in 1998. Yeah, we talked a little bit about that, the cultural differences. And I mean, you're right. People are very, very stoic in Japan. Mm-hmm. I mean, especially the business suits. And so We were at
Although particle theorists don't wear suits, so that's a big thing. When there's a conference, there's a particle physics conference in Japan, and in the same location there was another conference going on, and the receptionist could tell which conference. If somebody shows up in suit, they would direct them to one way, and then if somebody comes up with a T-shirt and shorts, they are particle physicists.
I mean, there's also a weird drinking culture in Japan where if like the boss wants to go out and drink, the subservients do.
That's the flip side of strict social, norm. So like when they are in the workplace, when they are sober, there's a strict social hierarchy that they should follow. But of course, that is not sustainable. Right? They need some outlet. So once they go to drink, then young people get anything they want to their senior people. So that's the way it works. That crazy drinking thing is necessary.
Yeah.
Otherwise, everybody gets.
I mean, but there's genuine concerns about like too much work hours, not enough people having kids. I mean, you still have family there. I mean, you keep up on local Japan politics and.
Not much, but yeah, I think the population is decreasing very rapidly. I think every year, maybe population that's equivalent to like 3 times of Tallahassee is disappearing from Japan.
That's crazy. So what is that? That's 600 to 1 million a year.
So, but nobody wants to have kids.
Yeah. Well, at some point they're going to have to open up to immigration, right? That's the only way you can sustain that population. Oh, we got a boss.
I didn't get any chance to power up. I don't know what happened. Oops.
Yeah, so this one we don't have infinite lives. It only gives you whatever the 3 you start with.
So there should be I missed shot balloon. So there's a balloon that says shot.
Oh, you can buy.
And then
upgrades.
so basically you collect coins from enemies and then you buy weapons. That's how this thing works. I missed the shop.
So no one has requested factoid. Someone should spend their internet units requesting a factoid, because Take has a few fun ones that he has on the list. So I'll start you out. Here we go. There we go. Non-dairy neutrino has requested a factoid. Take, which one do you want to go with? I think you can pause. Maybe.
I choose or they choose?
Oh, you can pick any. You wrote a few of them down.
Yeah, so since I talked about gravity... Oh, this is a shop.
Oh, there it is.
Do I have enough money? So let's see. I have 2,000.
Huggy Beer, welcome to the stream. Thank you for the request of factoid. Now you have 2 factoids that you have to drop. He only has 3 written down, so...
And maybe jet engine.
Oh, I see. You just upgrade.
Yeah. Wait.
Oof.
Forgot to choose that weapon.
All right. So which factoids do you want to do?
Yeah, so this gravity versus electricity. Yeah. So should I read? Or?
Yeah.
Okay.
Or just share it. Yep. While playing. No worries.
So the ratio of the gravitational force to the electric force between 2 electrons at rest is 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 43.
Negative 43.
Yeah.
So there's
43 zeros.
10 to the 43 difference in the impact of electrostatics
Yeah, so
versus
this is how
gravity.
weak gravity is.
I didn't know it was 10 to the 43. That's insane.
And this big hierarchy in the strength of force is one of the big questions in theoretical physics. why is such a large number? And if there's a fundamental equation, this fundamental equation that we don't know yet has this big number.
Has to describe it somehow.
It's very strange.
All right, are you ready for NARC? It is time.
Sure. Yeah, I don't know this game. But
Well, that's the best part is that you're playing a game you've never played before. It doesn't matter if you're good at it. So original NES. So anyone not familiar with the stream, this started out as a joke and now it's a tradition. We close the night with a speed run of the game called NARC. It's this terrible bargain bin game for the Nintendo Entertainment System. But we have every one of our guests run it as fast as they possibly can.
Yeah, when you mentioned this, I got very confused because my son is just learning FARC and NARC in his geometry class.
That's fair.
Yeah.
All right, before we start, we have one more request for a factoid. You want to do...
Okay, so
that first one's fun. I like that one.
So a black hole of the size of a coronavirus, which you are very familiar with.
Virus is very small.
So coronavirus is about 0.1 micron, 100 nanometer. That's the diameter of coronavirus. A black hole the size of a coronavirus would weigh as heavy as a giant piece of rock about 100 miles across.
That's crazy. It is underappreciated, the density of...
Yeah, that's how dense black hole is.
Yeah, that's crazy.
Size of coronavirus.
You said 100 nanometers equal to a 100-mile rock is insane. All right, go ahead and press start. So forward and backward, you're going to go to the right. B button tap is jump. B button hold is squat. A button tap is rocket. A button hold is bullets.
Okay.
All right, you're off to the races. So yeah, it's basically go right.
Infinite life.
Infinite life, infinite bullets, infinite rockets. Your goal is
never
just...
mind the enemies.
Nope. Just go right, find a door, go through the door. Man, coronavirus, like...
Yeah, 100 miles across rock.
That is absolutely insane. So yeah, this is pretty much you walking to new rooms and going to the right and finding an exit. Man,
This is the game I should have played while talking about physics.
so you gotta grab that red card. Yeah, this is pretty mindless. You don't have to focus at all. Plus cheat codes. These shooters are pretty good on that. Huggy Beer, I've always been petrified of black holes. Would we survive a black hole that size in direct contact with the Earth? That's interesting. So let's say a coronavirus in proximity to us. Would that just chew up the entirety of the Earth?
I don't think it would destroy the Earth. But if let's say this, so imagine, so you have to
touch that thing and then go through the door. Yep.
So this is a big rock, right? I mean, it has a gravitational force that is equivalent to this big piece of rock that is basically as big as half of the distance between Tallahassee and Jacksonville, right?
Mm-hmm.
So it's a huge rock. You have to drive 1 hour to go from one end of the rock to the other end of the rock. And the gravitational attraction from this mass is not small, although it's not as big as this string. But so let's say this coronavirus black hole goes through the downtown Tallahassee, and we will feel it, I think. Although we wouldn't be killed by it.
That's interesting.
We would,
You'd be like leaning
so
left.
Even gravity goes down straight down.
Yeah.
We will feel if we measure the direction of gravity using pendulum or something.
Yeah.
I think we should be able to.
But would that be enough for us to feel it? Like you'd get a sense of something pulling on you?
I'm not sure.
I mean, pendulum, you can get pretty accurate measurements, right?
Especially you're drunk. I don't know if
feels like it's happening right now. Man, that's pretty intense. I mean, and it's not enough. So this part, you got to shoot the guys wearing the black coats with bullets. So holding A, and one of them's going to drop a blue card. And shoot the dogs. Sorry, you're shooting dogs in this game. Hold both buttons, and you'll squat and shoot. There you go. Yep. And then you're going to shoot the guys in the black suits with. And one of them's going to eventually drop a blue card. Yeah, so this is, in the gaming biz, what we call RNG, where it's just random number generator. So that wasn't a blue card, so you have to keep shooting these guys. Shoot the brown guys, go back to the door, For some reason, you have to do it close to the door. Non-dairy neutrino. New game, drunk or micro black hole. That's one. Non-dairy, come up with an emote strategy for that one, because that's perfect for our Ask a Scientist guest. Drunk or micro black hole.
I mean, I need to calculate to be sure. But I mean, calculation wouldn't be difficult. But
so you have to be near this door. I don't know why. It'll only drop when...
But for example, I know things like if the
So bullets on these guys. Hold it. Not rockets. Rockets, they won't drop anything for some reason. But bullets, they will.
what is that blue thing?
It's a chemical vat. These are chemists that synthesize drugs.
So this is an American game.
Yep. So this is one of the games...
Is this sold in Japan too? Or?
I don't think so. Well, it might have been. It was an arcade game in the early 90s. But it was one of the games that, because of the ultra-violence, this is one of the ones that led to the, like, rating system for games in the United States. So this and Mortal Kombat and a few others really turned the tide on gaming rating systems. So go to that. Those guys... Maybe try
I
it.
think this is more violent.
Try it. Nope. Still got to shoot him. So yeah, this
is more violent than Street Fighter, Street of Rage kind of games.
Yeah, I mean, you do blow up people.
Yeah, pixel.
There it is.
Oh,
all right, blue
safe.
card. Yep, and now door or a key card. Hit the slot. A little further, and then go through the door. All right, new game, drunk or micro black hole. I failed my sobriety test because of a micro black hole.
Yeah, so I'm not sure. I mean, I never calculate this. It would be just some little estimation on a piece of paper, but I never actually estimated how much force we would feel. But for example, I know that the due to global warming, glacier on Iceland is melting.
Yeah.
And so the
Just keep going right.
actually so if you if the ice melts, normally you would think that the sea level would rise, right? But actually in Iceland sea level is going down, and that's partly because the glacier is gone, so the earth kind of get lifted because there's no weight on it. But another effect is that when there was a glacier,
So keep walking right. No advantage in
the
killing
gravitational pull of the ice of the glacier was pulling the ocean water. But now ice gone, the ocean just went away. So the combination of these effects led to the lowering of the sea level.
I love that somebody's done that
Fishermen are
math.
having a hard time because the sea receded and stuff like that.
So you can jump in this car and you'll drive for a little bit.
Okay.
You'll probably run into a wall
Ooh.
or a bomb. Unless you memorize the pattern,
Anyway,
it's
so-
impossible to do
So
that.
I'm saying that the gravitational pull from the ice, the glacier, is probably similar to the gravitational pull of the rock, right? Of the similar size.
Oh.
So the rock is more dense than ice, about by 5 times or something. I think I would say the density of a rock is probably 5 gram per square cubic centimeter, something like that. So that's more dense than ice, but in the level of order of magnitude, I think they're similar, right? So if the melting of glacier on Iceland can affect the sea level, then
So you'll jump over this. Tap
Jump
B.
over.
Yep. There you go.
okay.
Sorry, I was missing that.
Then the certainly micro black hole of which has the same mass as the
Yeah, just keep going.
same mass as the giant piece of rock will have a non-trivial gravitational effect as well. And I think the difference is that you can get a lot closer to the coronavirus, right? Because nothing is in the way.
Yeah.
So if you get closer, that the force goes up because of the universal globe. So if you are very close to the micro black hole, you feel very, very strong gravitational force.
I mean, and it would grow over time.
Yeah, because they will suck other things.
Mm-hmm. So eventually it would probably consume the Earth. Is that reasonable?
Yeah, I mean, that might take a long time. Yeah. Again, there's a piece of paper I could estimate.
That's awesome. No, you should give that as a physics test question.
Yeah,
How long would it take to consume the entirety of the Earth if you had a black hole the size of a coronavirus? That's pretty amazing. All right, Lori has requested a factoid. You want to drop the last knowledge bomb?
Yeah, so let's number 3. So there used to be about 1,000,000,001 matter particles for every 1,000,000,000 antimatter particles in the early universe. All of them annihilated except for the one that became us. So
that's a billion.
Means so for every let me repeat. So every 10 billion antimatter particles, there is 10 billion plus 1 matter.
Mm-hmm.
So, and then they all annihilate. So when the matter meets antimatter, they annihilate. Became energy. And then this one matter particle survive for every 10 billion. And that one became stars and galaxies and human beings.
So we are the
We are very, very,
0.00001% of the what is that? 6 zeros? No, 9 zeros.
No, it's 10 zeros.
10 zeros.
10 zeros. Yeah.
10 zeros. 0.00000000001% of the original mass of the universe. That's what we are. You're just walking right. Just hold right.
Yeah.
I'm gonna get you through this game.
Somehow I have an instinct of pressing B to go fast, like a Super Mario.
Like Mario.
Pressing B will just
Yeah, makes you slower in this game. No, this is the NARC saunter right here. This is how fast he walks until you hit a car. And if you stay on the bottom, you're good for a while here. But yeah, there's a very particular pattern you have to memorize. I apologize. This game is terrible. Keep walking right. That's your goal. Just hold right.
So this bomb?
Yep. Those are mines? I don't know. You know, war on drugs. That's a whole lot of energy heating up one particle.
Who's this guy?
Codemaster, I will not repeat that. But for someone that speedruns, hey, fun factoid, Codemaster, is I'm the former world record in speedrunning this game, actually. The world record holder beat me by 3 seconds, so yeah.
Who is the world? Sorry, who is...
So I used to speed run this game. Yeah, it started out as a joke on stream, and then I committed to running it as fast as I can, and I figured out a glitch on the final boss that saves like 25 seconds. And so I became the world record holder, and then
cool.
I was in contact with the previous world record holder, and I told him how to do the glitch, and now he beat me by 3 seconds. So I'm no longer... But yeah, any percent will count it. All right, you keep walking right.
Yeah, this wall looks like just standing right.
So it's supposed to be garbage cans. So yeah, keep holding right.
Go to the uppermost lane to avoid that thing, but apparently it's blocking the whole thing.
Yep.
It looks different. It looks like... I see.
Yeah, if you go to the bottom, you can just walk right. This game is so broken. Yeah, it's just hold right. You don't even have to kill anyone. Just keep going to the right. Codemaster, I have a speedrun tutorial if you're interested in speedrunning NARC. So if you want to learn how to do this game really, really fast, we have a link to that. What's interesting is that the speedrun is actually one of our most viewed videos. There we go, I'll share a link. All right, here it is, 30 minutes to figure out how to run a video game in 9 minutes. There you go, Codemaster. Just pick up an NES controller or use the keyboard. But yeah.
Oh, I died.
Basically walk right, go as fast as you can 2 doors. That's the entirety of this game. All right, we have about 15 minutes left. If anyone has questions on particle physics or how theoretical particle physics and how it relates to magnetism or astrophysics or quantum mechanics, Take is happy to answer your questions. If you have them, throw them in chat. Now's your opportunity to talk to a theoretical particle physicist who studies standard model and deviations from the standard model or holes in the standard model and how you fix them with new things like, I guess, relativity. You incorporate that.
Yeah, relativity is already incorporated.
It is in the standard model.
Yeah.
So what's missing from the standard model?
Well, so dark matter is definitely missing. And origin for neutrino masses that I talked about,
right.
that's missing. And in the standard model, there is no mechanism that can produce this. So I just talked about there's a, for every 10 billion antimatter particle, there's a 10 billion plus one matter particle. Standard model cannot get that one part.
So you're going in that door.
The standard model predicts the same amount of matter and antimatter and antimatter. So we cannot explain why we exist. So
you're going to grab a silver card,
That's,
that card, and then you're going to go through this door, but don't keep pressing up or you'll go back in. No worries. You know, because I said that sentence, a lot of people do that. So after you go through the door, don't press up anymore. Huggy Beer's revisiting our TV show or movie that gets science right and wrong. So earlier we talked about, you know, Big Bang Theory being a reasonable representation of particle physicists, or at least how they might think about the world. You talked about Interstellar as being good. We talked about some things being bad that just don't get physics right. Is there any other examples you've thought of? Any other movies that stood out to you? Oh, no worries, Huggy Beer. I'm glad you mentioned it because it'd be tragic if we went through an entire guest without asking our favorite questions.
So for Big Bang Theory, let me clarify that. So I think it's a pretty good representation of what particle physics might be feeling socially inside. That's what I think. Yeah. We don't say all of that because we are more socially trained than Sheldon.
So you're going to go through that door.
That door.
And then you're going to go left.
Oh.
That way. And what you're going to do is shoot those Rambo guys with bullets as they're reasonably close. But not rockets, just bullets. Yeah, I would love to see a research study on like quantifying percentage of like autism spectrum and ADD, things like that per discipline. Physics versus math versus chemistry, biology, social sciences.
I think it's pretty high. I mean,
it has to be.
I'm sure I have some.
Yeah, I mean, most of us are on the spectrum somewhere.
So
yeah, you're going to shoot
yeah,
those
that's
guys.
like an associate with Sheldon.
Yeah.
Yeah, and Lenny and those characters.
So you're going to shoot the person
Wait,
in
so how
white. So the white coat, the guy, the Rambo guy is going to drop the green card. So you're going to have to shoot this person until the Rambo character shows up. And then you're going to have to shoot the Rambo, that one with bullets.
Rambo?
Yeah.
Movie Rambo?
Yep. I mean, he's got like bullets. So go back to the left and you're going to shoot them with bullets at reasonably close range. Yep. So not rockets, not the tap one, but the hold one when they get in close range. Yep. So not that far away. For some reason, it won't drop it if you shoot them that far
So
away.
if I stand here, then...
Nope, it won't ever drop it. So there's stupid rules that dictate this game. So go back to the left. But don't shoot them at long range, because they'll never... Yep, there we go. I don't know how it works. My brother and I have learned way too much about this game, but for some reason there's a certain distance you have to shoot them with bullets and then they'll drop a green card. I don't know the rules that dictate it, but so it goes. All right, last minute questions. We have about 12 minutes left while Take beats NARC and wins the war on drugs. Particle physics, if you want to know any questions. So I'll ask one of our other standard questions. If there was one thing you wanted everyone in the world to know about, you know, particle physics, or something that, you know, people misconceptions or get wrong, or something you'd love for everyone to know, what would it be? Go right. Keep walking right.
Let me see. So one thing, maybe like the media, when they cover physics, what they get wrong. So they always often say that physics is broken. Einstein's wrong.
Yeah, exactly.
Quantum mechanics is wrong.
But they use words like destroyed. Newtonian physics is obliterated.
That never happened in physics. Physics has never been broken and will never be broken. And it's, I mean, I get email all the time saying that Einstein was wrong, Schrödinger was wrong, and that kind of stuff. But
keep going right. Just keep walking right. Just hold right.
Yeah, that doesn't happen. I mean, there are subtleties, and then we make mistakes at the frontier of the research. But we never find anything wrong in the part that is 200 years old. That's not. So in that sense, for example, when relativity was discovered, Newtonian physics didn't break. Right? We just discovered the boundary beyond which Newtonian physics is not applicable. And when quantum mechanics was discovered, classical physics did not break. Classical mechanics was never wrong.
Yeah.
We just discovered the boundary, right, of applicability. It's always like that. So
for most people's lives, Newtonian physics gets the job done. If you want to catch a softball, Newtonian physics math is fine.
Then it never broke.
So you have the red card already. Yep.
Oh, did I?
Yep. That was just from earlier. You wouldn't have known that. All right. Non-dairy neutrino wants to know, what's a good way to get started in particle physics for a physics grad? I know Griffiths has a very small book on it, but I'm not sure what is particle physics other than there's these things that aren't composed of smaller things. So what's a good particle physics for dummies on a graduate student level? Is there a good book or a reference? Keep going right.
Instinct to kill.
Yeah, no, exactly. There's a clock. That's the hard part about speedrun. So the record speedruns, you basically don't kill anyone until the final boss. You just go as quick as you can.
But there is no B button dash.
It's just a slow saunter. So do you have a physics book do you like?
A physics book?
Or some primer on particle physics? Yes, non-dairy neutrino. That was a clown with a knife.
There's a good book by Perkins about experimental foundation of particle physics. Griffith and Perkins are good introductory books. So those books are good for learning particle physics without going into too much detail of quantum field theory. But eventually, you have to learn quantum field theory to do real calculations.
All right, so here you get to kill somebody. You have to shoot the guy in the wheelchair with a rocket. So you're going to tap A. Yep, that's a sentence I utter every 2 weeks on this stream. You have to kill the guy in the wheelchair with a rocket.
There's a discussion on the rating.
Yes. Oh, Codemaster Quack. So this game was originally released in the arcade. I'm very surprised Nintendo, which has a clean-cut reputation, released this game. They replaced all descriptions of crack with quack. So they don't want actual drug mentions. They didn't want to mention weed or anything like that. So they replaced it with random words that sound the same but are not the same. So yeah, fun factoid on NARC history. Oh, there you go. 2 down. Nice. Quack cocaine, absolutely. All right, one more time and you should be good on the boss. Thankfully, the game's almost over, actually. Oh, there you go. One more gold card. He'll drop a card. Stay there, stay there, stay there. Yep, that card right there. And then you'll go through the door. And then you have one more boss phase. Yeah, I'm all for the quantum description and interested in the group theory representations like electron SSU2 times O4 or whatever it is.
SU2 cross U1.
Yeah. Oh, cross. That's cross. Okay. It's kind of fun as we use group theory in chemistry a lot. So this is the final boss. So what you're going to do is go to the top of the screen. And what you want to do is jump and you have to rocket him in the hat. So I would walk away from him a bit, maybe go to the right. And you'll turn around, you don't have to go towards him, but you're going to jump and on the way down, tap rocket. So it's tap B and then tap A. But yeah, group theory is just some really elegant mathematics to describe a whole lot of symmetry things.
Yeah. I think chemistry probably use point groups more.
Yep. Yeah, no, point groups are go-to.
Continuous groups like SU2. And
so go, like I would get, you know, pretty far away and then stop, turn around and just jump. You don't have to walk towards them. So tap B and then you'll tap A on the way. That was pretty close. And then walk away from him again.
Tap B once, what happens?
You jump and then when you tap A, it does a rocket.
Tap twice.
So you have to tap B once to jump and then on your way down on the jump, you have to tap A to shoot him in the hat with a rocket. Codemaster, this is all in the tutorial, so if you want to speedrun this, I'm the moderator of the speedrun.com NARC subcategory, so feel free to submit your run. Yeah, there you go. So you're going to tap B, and then on the way... There you go! Okay, rockets to the face. One more rocket to the face. Alright, now it's just bullets to the spine. And so what I would do is, like, walk down here and walk away from him quite a bit. Exactly. So press okay, go down. So you can't shoot him up. So you're going to turn around and just hold the bullets. So not rockets, but bullets. Hold the A button. All right, so some people say quantum mechanics is random. What does randomness mean, and is that scientifically accurate? Oh, that's interesting. Is quantum mechanics deterministic at some level?
That in quantum mechanics we predict probability distribution.
Mm-hmm.
So probability distribution is accurately predicted.
So you're going to walk this way, turn around, and bullets. So you're going to hold A instead of tapping it.
Hold?
Yep.
Yes.
There you go. Yep. And then you're going to walk away, and you're going to do it again. So walk to the right, get away from him, turn around, shoot bullets back at him, move around up and down. And just kind of, you have to shoot his vertebrae. But you can't do it from the bottom, you have to do it from the center. This is the worst boss in the game by far. Oh, I apologize. So sorry, randomness. What does randomness mean in quantum mechanics?
So it means the prediction of a theory is a probability distribution. So if electron is electron, for example, electron sitting right here has two possible states like heads and tail of a coin. And then quantum theory can predict in a given situation what's the probability for heads and what's the probability for tails. So when you do the experiment to observe the electron, you sometimes see heads, tail, and you can measure the probability by doing many repeated experiments, and then predictions agree with the theoretical prediction of probability. So it's totally scientific. So we make predictions and we measure we do the experiments to check the predictions.
So I'll give you a hint on this one. Don't tap A at all. Like when you turn around, just hold that A button and it'll unload bullets into them. And you want to be, somewhere in there. You can't be at the bottom of the screen and you can't be on the top of the screen because it doesn't hit for some reason. Oh, there you go. All right, turn back and we'll unload again. Lower on the screen. Nice. All right, go to the right. You'll go through one more door and one more room, and that is it, ladies and gentlemen. All right, if anyone has suggestions on who we should raid, the stream ends in about 1 minute. So if you guys have suggestions, absolutely, let's congratulate Take on beating NARC and winning the war on drugs. Congratulations. So the next level is the reward level. This is civil forfeiture, the level where you steal all the gold from the drug dealers. And that is the end of NARC. All right. If anyone has suggestions, Uncle Bill, I know you have someone if you're still around. If you guys have any thoughts on who we should raid, there's a few people on Arduino, Texas Space Agency, who does a bunch of blacksmithing on stream. He's a regular viewer of the stream, which is kind of fun. But if you guys have suggestions on who we should raid, shout them out now. All right, 28 minutes and 19 seconds. Congratulations.
So what was your record?
The record, the current, my best time is 9 minutes and 7 seconds. And the world record is 9 minutes and 4 seconds. So not bad. Sub 10 minutes makes you in the top 5 of the game. So congratulations. You've completed NARC. Contact your local DEA. Put your initials in. All right, ladies and gentlemen, we call that a victory every single stream. We win the war on drugs. Thank you all for joining us. It's been a pleasure. We always enjoy the questions. Taka, any parting words for the audience?
Sorry, what?
Any parting words for the audience? Anything you want to share before we leave?
I think I really enjoyed this stream, and I think I would like to do it again. And
You got to revisit some classics.
Yeah, definitely, I want to do it again, and then get more questions. And this has been great. So,
I mean, recapping, you beat Space Harrier and you beat NARC, so victorious.
with Infinite,
It still counts. We counted on this stream, so
yeah, I fulfilled my childhood dream of playing those games infinite times.
I'll tell you what. Next time you're on, I'm going to figure out for Salamander how to get infinite lives, so we can beat that one as well. I'm sure somebody's figured out a way to game the system. But Taki, thank you for joining me. It's been a pleasure. I learned a lot. A lot of fun factoids, a lot of fun questions, a lot of fun answers. So thank you for joining us. 2 weeks on April 12th, our next guest will be Dr. Lance Cooley. He's a mechanical engineer in the Department of Mechanical Engineering at FSU. He works on applied superconductivity and particle accelerators and like the mechanical aspects of how do you keep materials in that, really high stress environment without them blowing up. And it's a genuine concern. And so, yeah, he works at the Mag Lab, and he'll be our guest in 2 weeks. I don't know what he's going to play yet, but we're in touch and we'll figure that out. So yeah, join us again on April 12th. But as usual, it's always a pleasure. Stick around. We're going to raid some kind of nerd that's streaming something of some kind. I think Nerdweedo might be a good choice on this one. So yeah, thank you guys as always for joining us, and until next time.